by understanding age. So we talked about data types, some kind of data collection method, that's fine. But now we need to understand whether our measurement system is, first of all, in a good condition or not. Very important, yes or no? Particularly in a project which is data driven, the measurement system should be in good condition. All of you, please tell me, when I say measurement system and measuring instrument, are there any difference? Is there a difference between measuring
Yes, yes.
instrument
Yes.
and the measurement system?
Yes.
Yes,
Yes.
sir.
So what is
Yes.
the difference?
There's a
What is the
difference.
difference? Measuring instrument
Instrument is a tool.
refers to the instrument that is used to collect the data.
Yes.
If there is
Yes,
any
sir.
problem within the measuring instrument, then the error might populate because of the poor condition of the measuring instrument. Yes or no?
Yes, sir.
So how can you eliminate this error? By
Through measurement system.
calibrating the measuring instrument.
Calibration.
We calibrate the measuring instrument. Probably no, we take care of the maintenance part of the measuring instrument. And all of these things we do, and so that the error that is coming from the measuring instrument can be eliminated. Agree with me, all of you? But even though you have a calibrated measuring instrument, does it mean all your data will be error free?
No, because it
No.
depends on operator to operator also.
Still measurement error can populate. And now the error might populate from the measurement system. Earlier I told you measuring instrument, and that you can easily get rid of by calibrating the measuring instrument. But for measurement system, there is no calibration procedure available. Agree with me, all of you?
Yes,
So
sir.
what is measurement system? Measurement system means it is the all the elements of your all the elements used in data collection is combinedly known as measurement system. What are the elements we use in data collection? First of all, we need a measuring instrument.
Measuring instrument,
It
appraiser.
is not your
that
measuring
procedure.
your measuring instrument is an element, is a part of your measurement system.
Yes.
And number two, we need an appraiser or data
Appraiser.
collector. And number three, we need some product which we will
Yes.
be measuring. Yes or no? A product and the characteristic. And number four, you have to give him proper instruction how to collect the data,
Yes.
how to
SOP.
hold the workpiece, how to hold the measuring instrument, and how to record the data. Everything you have to teach them. That is known as operational definition. I think yesterday we talked about operational definition, isn't it? So, operational definition. And over and above, the environment can also influence your reading. Am I right?
Correct.
Yes.
All these elements put together is known as measurement system. There are two requirements. Your measurement system should be consistent enough to produce the reading. What is the word I'm using? Your measurement system should be consistent enough to produce the readings. If measurement system is consistent enough, then the only thing you need to take care is measuring instrument. Okay? So the only thing you need to take care is measuring instrument. So now, which comes first? Which one we should focus on first? The consistency of the measurement system we need to focus first, or the condition of the measuring instrument we need to focus first?
Consistency of
Condition.
the
Condition of equipment.
Okay. But I recommend
There
you
is
to
one more
first
point, sir.
check. Yes.
Even this equipment is calibrated. That also important whether this particular equipment is appropriate or suitable or not for this particular characteristics.
Very good. Correct. So whether the equipment is appropriate for the particular data collection range. What is the range in which we are going to collect the data, and is this resolution of the measuring instrument and the range of the measuring instrument is in line with the data collection range? Yes, that's also a good point. So now let us do a small exercise and then we will be able to understand. Now, if I ask all of you, what is the current time? All of you have some kind of, an instrument to mesh to find out the time right now, isn't it? Please type the time right now. Maybe you can refer to any watch with you, and then you type the readings in the chat box. Let us see whether we are able to generate a consistent reading. All of you, can you see the readings are coming out in a consistent manner? Am I right?
Yes.
But one person, I don't know why he has mentioned five. Okay, he's from some other place. Okay, 5:44 p.m. And the majority, most of you have said 7:14. Oh, except Manoj, he's from some other place. Okay, but there is a small little variation. Can you see that some people said 7:15, but everyone else have said 7:14. But 8:40, why it is 8:40? I don't understand. So again, he's from some other place. And are you able to notice consistency in the reading?
Yes.
If this is not happening, I cannot use all of you in my data collection activity. Yes or no?
Yes.
If this consistency is not going to happen, and definitely I cannot use all of you in my project for the purpose of data collection. So which comes first?
Consistency.
Consistency comes first. Why? No, because there is a way by which we need to collect the data and I communicate. And what is my minimum expectation is all of you should collect the data in the same manner. There has to be a consistency, but achieving consistency itself is a big problem. Hope all of you agree with me. It's not that
Yes.
much easier, isn't
Yes,
it?
sir.
So,
Yes.
so since there are several elements, easily things can go wrong. And hence, there can be a variation. If the variations are very, very minimal, like how we are right now noticing in the chat box, then it is fine. So for the consistency of the measurement system, we check first with the help of a tool known as gauge R&R. A tool known as gauge R&R. Gauge R&R is an estimate of repeatability error and reproducibility error. Gauge R&R is an estimate of repeatability error and reproducibility error. What is repeatability error? The variations in the measurement of single appraiser while measuring the same product multiple times. If you are measuring the same product, same characteristics multiple times, ideally all your readings should be same. Yes or no? If your readings are not same, then you can understand that particular individual is populating error. Yes or no? Because he is measuring the same thing multiple times, and so he has to give the same reading. If that is not happening, you can understand he has a tendency to populate error, and such form of error is known as repeatability error. All of you are with me on this?
Yes, sir.
And number two, same part, same characteristics, but there are different appraisers. There are different appraisers. So in an ideal condition, both appraiser should generate the same reading because both of them are measuring the same thing. But if that is not happening, you can understand there is a variation between the appraiser. There is a variation between the appraiser. This indicates that two or more measurement system, they are not agreeing to each other. This form of disagreement is known as reproducibility error. Clear, all of you? So, like our one of our participants said, I think Sonova, okay, selection of the measuring instrument is also very important. And selection of the measuring instrument is mainly based on the measuring range. Another thing is resolution. In other words, resolution is known as least count. In other words, resolution is nothing but least count. So what is least count? The minimum signal to which your measuring instrument can respond. The minimum signal or the lowest signal to which your measuring instrument can respond. That is what is known as resolution. I want all of you to open the stopwatch in your smartphone because all of you have a smartphone. There is a stopwatch in it. You can open the clock application then you can open the stopwatch. And can you find out the resolution of the stopwatch? Nothing but the least count of the stopwatch. And then please type the resolution or the least count in the chat box. So if the resolution is same, it confirms that all of you have a similar measuring instrument. That is very, very important for the consistency in the reading. Am I right? If each one of you have a different instrument having different resolution, so resolution means the lowest signal. Resolution cannot be 0. Least count cannot be 0. 0.01 second is the correct answer. And I could see somebody saying 1 second. 1 second is not the resolution. 0.01 second. What is 10 millisecond? 0.01 second. So 0.01 second is the correct answer. So all of those of you who are not able to type 0.01, please correct yourself. The least count is 0.01 second. And now I believe all of you have the same measuring instrument. So I want to do a small experiment here to check whether we all as a measurement system, are we in a good condition? Are we in a good shape or not? Shall we do a small exercise? All of you are
Yes.
ready?
Sure, sir.
So what will I do is, I will play a video from my side. I will play a video from my side. Maybe a song of your choice. If any of you have a choice of any song, you can let me know on it. I will open YouTube and then play the song for you. What all of you have to do is just measure the duration for which the video is playing. I will abruptly stop the video sometime. Then what you need to do is you must immediately stop the stopwatch. All of you understand the operational definition. When I play the video from my side, you can immediately hear the voice. As soon as you hear the voice, you should start running your stopwatch. Press the start button. Then without any notice, suddenly I will stop the video. Then you should stop the stopwatch and then type your reading in the chat box as it is. And all your reading should necessarily be in terms of seconds with the 2 decimals. I will type probably one sample reading for you so that you should also type in the same manner. And see here, I have typed one reading. Can you see that? Oh, 1 minute, I'll do that. Everyone, okay. Can you see my reading? 46.57 seconds. That means I played the video for 46.57 seconds. The measurement is only in terms of seconds with the 2 decimals. I want the reading in this manner only. Please do not mix up your measurement with the minutes, seconds, hours, and everything. You are not allowed to do that. Because when I feed it into any computer, then it will create complication in the calculation, right? To avoid that, everything should be in seconds. And I expect all of you to demonstrate consistency while doing this exercise. Will you be able to do it? Then you will realize how much challenging it is to achieve the consistency. Same instruction, same song, right? And then, all of you are using a similar instrument because the resolution wise it is same. And so we must have it, right? So let me find out what is the song. Toba, somebody suggested water bucket song. What is that water bucket song? Okay. Then Rudripat song, I don't know. Okay, let me try. Yeah, you have to help me with the keyword, right? So since we will be playing, there are 2 types of error. One is repeatability error. The other one is reproducibility.
ಅದು ಹೋಗಲ್ತ್ರಿ ಅದೇನೋ
The
ಸ್ವಲ್ಪ
error
ಪ್ರಾಬ್ಲಮ್
within
ಆಗೈತಿ.
the single measurement system. The error within a single measurement system is repeatability error. The error between multiple measurement system is known as reproducibility error. Both of them are forms of inconsistency. Clear? Both of them are forms of inconsistency. So you need to somehow quantify them. You need to somehow estimate them. If I involve all of you in my project, how much error you all will populate? Will I be able to estimate? If I perform a pilot study, Probably I may be able to estimate yes or no.
Correct.
So I perform a pilot study. I don't go for a real data collection. I'll not go for a real data collection. Rather, I will perform a pilot study. Some sample data I will collect using all of you. And then I will try to measure the variation in the data. How can I measure the variation in the data? There are three measures of variation. Do you know that? One measure is range. One measure of variation is range. Like earlier also, while looking at the chat box, the maximum reading was how much? 51. The minimum reading was how much? 45. And so what is the difference? 6. 6 seconds is a huge variation. Can you see that?
Correct, sir.
6 seconds is a huge variation. So in the place of 6 seconds, if you have produced only 2 seconds, then I will really consider the system as a good system compared to 6. Yes or no? So one way I can measure the variation is or estimate the variation is range. But the best way I can estimate the variation is standard deviation. The best way I can estimate the variation is standard deviation. After calculating standard deviation using the data, I will multiply the standard deviation by 6. Because any process will have a spread of how much? 6 standard deviation. Yes or no? We
Correct.
studied this. Any process will obviously have a spread of 6 sigma. Here the spread is variation. Here the expectation is no spread. Everything should be the same value. If everything is on the same value, the total spread will be 0. But if the values are different, gradually the spread will increase. But we very well know the total spread will be equal to 6 sigma. Somehow calculate sigma, multiply by 6, you will get an estimate of repeatability error. Using the same method, you can also get the estimate of reproducibility error. I don't want you to worry right now about the calculation part of repeatability error and reproducibility error. Please understand the logic and the concept. Okay? And the formulas and other things, yes, I will teach you when we revisit the measure phase during the second time. All right? So there is repeatability error, all of you know. There is reproducibility error, you know. Both of them together, if you sum up, the error will now be known as precision error. All of you understand? The sum of
Sir, can I
repeatability
repeat this
error,
once?
the sum of repeatability error and the reproducibility error is known as precision error. What is precision error? The error due to inconsistency in the measurement system. There are two types of inconsistency, repeatability error. The other one is reproducibility error. If I add them up, what is the name given to it? Precision error.
Precision.
Now this precision error should be compared against the customer provided tolerance. Should be compared against the customer provided tolerance. So customer provided tolerance. So maybe let me open something or I will show the PPT so that it will be easy for you to follow me. Module 2. Yes.
Sir, module 2, you will share with us post the class, right?
I will share, no problem. But please note, it should be there in your material. But you know what happens? For those who opted for the green belts, you will only have some extra content. But that extra content, will be covered in the upcoming weeks, right? But okay, anyways, to bring the clarity, I will share it. Don't worry, right? Okay.
Thank you,
So
sir.
see here, yeah. So why are we doing this study? Because we are on a project. We are driving a project. So we must reach the target. We must reach the destination. Imagine you are driving a car. Now also you should reach the destination without any issues. If you want to reach the destination, then you must have a windshield. which gives you a clear vision of the road. If your windshield is not clear, it is contaminated with a lot of, what to say, the dirt, then what will happen? The road will not be visible at all. Then you will not be able to drive properly. Then you may not reach the destination. You may meet with some kind of, unnecessary challenges. The same things will happen if you prefer to work with a data which is contaminated with error. Yes or no?
Yes.
So particularly if your project is data driven, you must be cautious about this, right? So working with the data which has a higher amount of error is as good as closing your eyes and driving a car. We don't know what will happen, right? So the same thing might happen in your project also. So make sure you check your windshield before starting your car. Clean it, wipe it out. Any problem, you please wipe out, and so you get a clear vision of the road. So there are certain definitions available here: repeatability error and reproducibility error. We now demonstrated, right? We have experienced it. What is repeatability? The error. The error within the single appraiser. You see here, all the readings are produced by same appraiser. Can you see a blue color curve?
Yes.
And now this person's reading has got a spread. The spread is not expected here, isn't it? So the total spread will be how much? 3 sigma on the right side, 3 sigma on the left side. So 6 times the sigma of the readings of this particular appraiser will be the repeatability error contributed by this appraiser. Now I am showing you 2 appraiser or 2 gauges or 2 measurement system, one black color, other one red color. Now which one is bringing more error and which one is better?
Gauge A is better.
Gauge A is better.
Yeah, the black color one is better because the spread is smaller. Can you see that? So the lesser the spread, the better the measuring instrument. But in order to talk like this, you have to design your data collection experiment properly. You should ask the appraiser to measure the same part only multiple times. Don't give him different parts. If you give him different parts, then the spread is expected. But if you ask him to measure the same thing over and over again, then the spread, should be minimal. And now what are we doing? We are giving the same part, same characteristics to multiple appraiser. Look here, for appraiser 1, appraiser 2, appraiser 3, appraiser 4. Can you see their average readings are now moving right and left? If the average of first appraiser is moving away from second appraiser and again the third appraiser is moving away from second appraiser, that means reproducibility error is populating. So pick up all the averages and visualize the averages. Then there will be a grand average in the center. Can you see? A grand average in the center. With respect to the grand average and the other averages, will be creating a spread. Can you see that? With respect to the grand average, the other averages will create a spread. So this spread is known as reproducibility error. Now appraiser 1, appraiser 2, appraiser 3. Are they agreeing to each other?
No.
Thank you.
1 and 2 somewhat okay. Can you see here? 1 and 2 more or less same, more or less producing similar reading. But appraiser 3 is completely away from 1 and 2. Can you see that? Now what are you supposed to do? Somehow make the appraiser 3 produce readings similar to appraiser 1 and 2. All of them, should produce the same reading so that your reading is free from reproducibility error. So now coming to the understanding, repeatability error plus reproducibility error, we are going to call it as precision error. Precision error means a form of inconsistency. Now this precision error, we compare against the tolerance provided by the customer. What is tolerance provided by the customer? USL minus LSL. Can you see a ratio here? Precision error compared against the tolerance. This ratio is known as gauge R and R. This ratio is known as gauge R and R. If you multiply by 100, you will get it in terms of percentage. Clear, all of you?
Right.
And this gauge R&R must be less than 10% to say that our measurement system is good and acceptable for data collection. If the gauge R&R is in the range of 10 to 30%, our measurement system is conditionally acceptable. Conditionally acceptable means your process must be running in a very healthier condition, then only you can opt for the second thing. You understand? If your process is already weaker, then the second condition is not applicable. Now the third condition, if the gauge R&R is more than 30%, your measurement system is unacceptable. All of you are with me on this?
Yes.
You measure the process capability in terms of some metric CPCPK or sigma level or something. If the capability is really good, then you can even use the second condition, right? But first condition is absolutely okay. Gauge R&R should be less than 10%. Second condition, yes, if your process is highly capable, then it is okay. But third condition is never okay. Also, please note, only after ensuring that your gauge R&R is okay, you can proceed with the estimation of the bias. You can proceed with the estimation of the bias. So that's what we will be doing. So what is the first thing we should do? We should measure the inconsistency. Afterwards, we will measure the inaccuracy. So in order to talk about accuracy or inaccuracy, you need a standard part. You need some reference value or you need a standard value. Let us say you have a standard part of dimension 25.4 mm. Now you want your appraiser to measure this 25.4 mm 10 times. Can you look at the readings? There, can you see a variation? So that means it is because of the repeatability issue. Same person measuring the same part 10 times, but still giving different reading. This is quite normal. It will happen. Now, in order to estimate the bias or the inaccuracy, you have to first of all find out the average of the readings. How to get the average? You add all the 10 values and then divide by 10. Can you see? The result is 25.4051. Now find out the difference between the true value and the average of the measured value. Average of the measured value is this, true value is this. So the difference is 0.0051. 0.0051 is the bias. 0.0051 is the bias. Now this bias should also be estimated as a percentage of the tolerance. In order to do that, you have to divide this by the tolerance. And tolerance is given here, plus or minus 0.25. So what is the total tolerance? 0.25 on the right, 0.25 on the left. Total tolerance is 0.5. So 0.0051 divided by 0.5. When I convert that into percentage, I am getting 1.02%. Can you see your total bias is 1.02%? What is the industry standard? AAG guideline is, if at all there is any measurement error, it should be less than 10%.
Right.
And now the bias what we calculated is just 1.02%. That means it's okay. It's a good scenario. All of you are with me? But
Yes.
please note
Sir,
the
can
calculated
we
bias.
discuss again?
Yeah, the calculated bias is valid only if you perform the gauge R&R study in a fair manner. If your gauge R&R study is not performed properly, and if the gauge R&R is not less than 10%, then whatever, the bias you calculate, that bias may not be a proper estimate. Because consistency is a bare minimum requirement, yes or no? Only if the consistency is ensured, then whatever you calculate using your measuring instrument, it can lead to a valid conclusion. So the bias study must be conducted after conducting the gauge R&R study. Okay. Let me clarify this. Imagine you have a watch. You have a watch, you are wearing a watch and your watch is running 10 minutes faster. Your watch is running 10 minutes faster. Now, do you think you can still use your watch? Because you very well know your watch always runs 10 minutes faster. That means there is a bias in your watch. The bias is how much? 10 minutes. But the only advantage you have is the bias is a stable bias. Throughout the day, it is 10 minutes faster. Throughout the day, it is 10 minutes faster. So what you can do is, whenever you want to know the time, you can look at your watch and suppose if the time is 7:55, what is the actual time? 7:45. Do you understand? Because your watch gives a bias of 10 minutes. This is known as positive bias. If your watch gives an extra value, then the bias is known as positive bias. And how can you handle the situation? If the moment you know the bias is stable, you after generating the reading, you subtract the bias value from all the reading. Do you understand? This
Yes.
formula will be applicable only if the bias is stable. That is why I told you consistency is very important.
It says about.
Yeah, if consistency is there, then your bias will be stable. Yes, Vignesh, you want to ask something? Please feel free to ask.
Uh, Good evening, sir. Correct me if I'm wrong. I think that is the formula bias divided by tolerance into 100. Am I right?
Yeah, correct.
Okay, the bias is 0.0051. Divided by the tolerance value is 0.025.
No,
Is the
0.5.
tolerance
Let us take
okay?
a
The process
calculator.
tolerance is 0.25 mentioned in the sum. So I asked.
See,
it will take,
It's
it will
plus
add
minus
both the
0.25.
plus and minus.
yeah, plus minus 0.25, right side 0.25 tolerance, left side 0.25 tolerance.
Okay,
So the total is 0.5.
okay, sir.
So if you divide
Okay,
this is coming to 0.01. So to
okay,
express it in terms of percentage, I multiply by 100. So I am getting 1.02%. So
okay,
I
okay.
was talking about positive bias. Here, what you see here also you are saying a positive bias. Can you see here? 25.4 is the original value, but your reading comes as 25.40. So it's a positive bias.
Sir, 25.40, that always remains constant, or that is a given
Because that's a standard.
Average.
standard?
That is a standard part.
Sir, I have
That
one doubt,
is
sir.
like
Yeah, please,
predefined.
please. Yeah.
Sir, normally, see, as I told, we are in automotive industry. Every year, IATF audit will be there. It's a part of activity, MSA, we have to conduct. So regularly, different frequency, we do the gauge RR and report. See, normally we use good original calibrated instrument only.
Yes.
And our engineers are trained, whoever having more than 5-6 years experience only. They are checking the same method, same samples, the 25 samples or 15 samples we give them to measure 3 people. By the time
Correct.
also we are getting error. It is basically what we have to conclude. It is instrument error or appraiser error.
The root, see, I told you initially, I don't know whether you are attending from the beginning. The error populates from two things. One is the error can populate from the measuring instrument itself. If your measuring instrument itself is not in a good condition, it will have a
That's why I
bias.
told it is a calibrated, good new instrument. No error.
Yeah. No. Okay. Anyway, see, if that is ruled out, then the error is coming from your measurement system only.
Okay.
So what is measurement system? Measuring instrument, the data collector, the instruction you have given to him, the product you have given to him, The environment under which you are expecting him to collect, all of them are element of your measurement system. And you are very, very clearly telling that instrument is not problematic. You can exclude that element. So that means some attention is required on the other elements. Out of the other elements, environment you cannot control. The controllable elements are the instruction that you are giving to the appraisers. How to hold the part, how to hold the measuring instrument, how
Yes.
to record the reading, how to note down the reading, or the entire procedure. This is what is known as operational definition. All right, the
Okay.
operational definition must be free from ambiguity. But in spite of all the efforts, still there will be some error populating. What you can do is, after conducting the gauge R&R study, there will be a gauge R&R value coming in Minitab or whatever. Tomorrow, next week, we will discuss in detail, but since you raised the question, I am speaking about it. The gauge R&R value you need to look for. If it is more than 10% or more 10 to 30% or more than 30%, three scenarios. Less than 10%, yes, it's a good scenario. That is quite tolerable. But 10 to 30% conditionally tolerable. But more than 30% intolerable. Imagine it is more than 30%. So now, with the experiment conducted, with the data you collected as part of your pilot study, you need to visualize your data. Operator-wise, you need to visualize. Part-wise, you need to visualize. Component-wise, part-wise, what do you call? The error category-wise. Repeatability error is one thing, reproducibility error is other thing. You can actually, plot some visual graphs using which you can visualize, the variations. Part-wise variation, operator-wise variation. Yes or no? So what will happen? Which
Yes.
operator is contributing to more error? You will get that piece of information. Which particular part your measurement system is struggling to measure? Yes or no?
Yes.
If you have to measure from 1 ampere to 10 ampere, 10 ampere current, your measuring instrument and everything is measuring perfectly. But current lesser than 1 ampere, then they are struggling to measure. Maybe chances are there, isn't it? So which
Yes.
parts are difficult to measure? Which parts are easier to measure? All these pieces of information we can find out by referring to the pilot, data collected in the pilot study. We can convert them into graph and we can grab those information. With all these informations available, you can take some actions. Right actions. You may have to train your people. You may have to train your people exclusively on specific part type. Yes or no?
Yes, sir.
And you have to you have to educate your people to understand how can they bring the consistency. Say, for example, if somebody has to measure the motor speed and I give a tachometer, how they will measure? Somebody will switch on the motor and immediately place the tachometer and then get the reading. Another person might allow the motor to stabilize and then measure the reading. So definitely there is, they are following different practice. So that is the source of error, isn't it? So they are not agreeing to each other because there is a poor operational definition in place. I did not explain properly. I only said you measure the speed. So all of them followed, different procedure. Instead of that, I must clearly tell them, switch on the motor, wait for 2 minutes or 3 minutes. Then you measure the speed of the motor, record it. So like this kind of small improvement will make the difference. And slowly what will happen? The particular person contributing to more error, if you identify and help him, measure perfectly, the repeatability component will come down. Also, if you can find out which person is differing from the group, if you look at our own readings in the chat box, you will be able to locate few people differing, by a huge margin from others. Yes or no?
Yes.
Those are the contributors of the reproducibility error. So you need to figure out how things, went wrong and then what will happen? The reproducibility component will also come down. If both of them, if you are able to bring it down, then the total gauge R&R will come down, and hence you can start using the measurement system, provided all these improvements you have suggested, your measurement system continue to follow that. If they don't follow, and again there will be a problem. All right.
Yes, sir. Sir, actually, one example, sir, where we struggled, actually, same, we used to perform a 13 diameter, one dimension produced in our process machine part.
Okay.
The dimension tolerance is plus or minus 0.2.
Hmm.
But the ovality allowable is 0.1. There itself 50% error allowed. Unfortunately, we took to perform the MSA. We found error, we criticized the instrument and our appraiser also. Then what I did, for 13 mm, I brought standard pin. All standard pin, 25 numbers, same value. Then I have given that samples to the appraisers, standard instrument. Then particularly I could able to catch the appraiser variation. Because the dimension always, whatever customer giving, that part value will have two means contradict dimension, which will impact each other. One is diameter we have to control, other one is ovality we have to control. So the person, we cannot say that all person will measure at the same location. So someone will take a minor diameter, some people will take major diameter. The variation itself, there plays major role, and always it gives error in the MSc study. So I did standard pin, providing standard pin and calibrated zero error instrument. Then I could be able to control that appraiser thing, because most of the time our member either passing defective to customer or rejecting good part in-house. That is the problem we observed.
Yeah, if you wanted to prevent these things, that means, these are known as type 1 error and type 2 error in measurement, right? Manufacturer risk and consumer risk. Rejecting a good part is manufacturer risk, and accepting a bad part is consumer's risk. Both of them are happening because of poor measurement system in place. So what you need to do is, you must improve your measurement system, number one. Another thing is, operate your process in a safe zone.
Yes.
Operate your process in a safe zone. So if you operate your process in safe zone, even if you have a weaker measurement system, still the type 1 error and type 2 error cannot happen. You can still avoid that. But if your process, if your measurement system is weaker, your process is also weaker, you cannot avoid those challenges. Definitely, there will be, disagreements between you and the customer. There will be arguments between you and the customer, and that will certainly happen if you have both the process and the measurement system in a weaker condition.
Yes, sir. I
So
agree.
definitely one must be stronger.
Yes.
If your
So that's
process
why
is
we reduce,
stronger,
that's why we use only 75% only given tolerance. It's acceptable criteria for processing.
very good, very good, excellent. So if you use 75% of the given tolerance, your process is 4.5 sigma process. If you use 50% of the tolerance only, then your process is a 6 sigma process.
Understood.
If you consume 100% of the tolerance, then your process is 3 sigma process.
Yes.
In a 3 sigma process, where you are consuming all the tolerance given by the customer, definitely there will be risk, there will be challenges.
Defect outflow.
Type 1 error and type 2 error both will be happening, and then there will be no disappointments, manufacturer side as well as consumer side. So that's
Sir,
why
what is
we
safe
always look.
zone here? Sir, what is
That's
safe
what.
zone
That's
here?
what. That's what. The CPCPK should be 1.67 and above. If CPCPK is 1.67 and above, your process is centered around the target. Your process is centered around the target, and your control limits are placed well inside the specification limit. Let me indicate all of these things, in visual mode, then you will be able to better understand. So imagine all of you, this is your upper specification limit. Can all of you, are you seeing my screen now? Upper spec and lower spec?
Yes.
Very
Yeah.
good. And so where is the customer target? Customer target is here. This is target, right? So this is 100, this is 100.5, and this is 99.5. So this is the target and the limits given by the customer. Now, if your process is operating like this, how is your process operating now? Oh, sorry. How is your process operating now? It is consuming all the tolerance. Can you see here?
Yes.
It is consuming all the tolerance. So what will happen? The 10% of the parts you are producing here. No? Let me. Yeah. So upper spec, lower spec, and my process is consuming all the tolerance. So what will happen? The last 10% of the parts, you see here this region. Similarly, this region. In this region, if you produce parts in the hatched region, type 1 error will happen. Yes or no?
Yes,
sir.
Because you see, because this dimension, let us say this dimension is, okay, I said 100.5 here. And let us say you produced a part here, which is 100.45. Now your gauge has a 10% error. 10% error. That means there is a possibility of bias of 0.1. All of you are with me on this?
Yes, sir.
Yes, sir.
yes,
Because 100.5, 99.5, the difference is 1 mm. So 10% of 1 mm is 0.1 mm, which means your measurement system has a chance of giving 0.1 mm bias. Now, what is the part actually produced? 100.45. Now tell me, 100.45 is a good part or a bad part?
it is good part.
Good part, because it is inside the spec.
Yes,
But your measurement system can measure this part and produce a reading of 100.55. Yes or no?
5.
Yeah,
Then
exactly.
it
Yes,
is
sir.
Because it
bad
has
part.
a reading of 0.1. So a good part is getting rejected here. This is known as type 1 error, manufacturer risk.
Yes,
The vice versa is also possible. Suppose you produce here. Now the part dimension is 100.55.
and
Your
bias is
measurement system
minus bias.
Your measurement system can record it as 100.55 and classify it as good. Actually, the part is bad, but your quality checkers are now classifying the bad part as a good part, and finally, the good part will go to the hands of the customer. Why is this challenge happening? Why
Just
is
because
this challenge happening?
just because we are
Because
using 100% tolerance.
you are using 100% tolerance. Please note, if you are using 100% tolerance, then your process control limits and your process specification limits will
Are
be at
safe.
the same point, which must be avoided. Yes or no?
Yes, sir.
Yes,
Yes, sir.
Your lower control limit and lower specific, both are no at the safe. So your process is not, operating in the safer manner. So the better way of operating the process is, just a minute. So how can we operate the process? Now let me suggest you. If I operate my process in this manner, now tell me, do you think your bias of 0.1 will affect your conclusions?
no,
Let us say you produce a part here and this target is 100 here and actually produced part is 100.2. What will happen to 100.2 if I add a bias? It will be 100.3. 100.3 is still acceptable.
yes,
Even if I add a bias of 0.1, a good part is always classified as a good part. Can you see the manufacturer risk getting eliminated?
Yes, yes.
Similarly, consumer risk also can be eliminated, right? So all that required is, you don't go to the danger zone. What is danger zone? The zone closer to the specification limit, right? So that is the thing. So you should, for this, if you look at this process, the CP, CPK is equal to 1. Am I right? But if you look at this process, the CP, CPK are more than 1. In fact, it will be more than 1.67. If it is actually 2, when I say CPK equal to 2, what does it mean? My process is consuming only half of the tolerance.
6 sigma.
My process is consuming only half of the tolerance, 6 sigma capability. You are earning a salary of 2 lakhs, but your monthly expenditure or monthly expense is 1 lakh only. You are now doubly capable, isn't it? Even small, unforeseen expenses cannot affect your, what do you call, the smooth running of your family. Yes or no?
Yes.
1,000 rupees, 2,000 rupees here and there, if you spend extra, then also you will not have any problem because you have a surplus of 1 lakh. That is the advantage of consuming the tolerances in minimum quantity. If you have the habit of consuming minimum tolerance, then only you can think about offering warranties to your product. Do you understand? If you have already consumed all the tolerances, then you know what will happen during the warranty period? The moment the customers start using the product, your control limits, you know what will happen? The product will undergo wear and tear, yes or no?
Right.
Yes.
And within another few days, it will be out of spec, yes or no?
Yes.
And so, right after 3 months of usage, your product will abruptly fail in the field. And so, customer will claim all the warranty and everything. So, if you are talking in terms of warranties, you need to understand the critical parameters. And for those critical parameters, make sure you don't consume all the tolerance provided by the customer. Customer will give the tolerance. It doesn't mean that you can consume everything. Yes or no?
Yes.
Lower the consumption, more will be the field life for your product. This is, Takuchi's philosophy of quality. Takuchi is one Japanese quality guru who said variation is a quality loss.
Sir,
We all think that quality loss will happen only when we produce beyond the spec. But Takuchi is told, even if you produce the part within the spec, still quality loss is happening. Am I yes or no?
yes, sir. Sir, here we have one big challenge, sir.
Yes.
Normally, you told that to maintain that quality, the process should be centered. So from quality side, always we give alert to production department. You have to change this time your tool. You have to maintain tool history card. Time you have to change.
Correct.
We give alert, but production team, what they are doing, like thinking cost reduction activity, they are not changing that tools. They are telling that still it is running okay, no issue, we will change later like that. But saving of 5,000 rupees tool cost, customer and we have many experience. We spent a lakh rupees, like customer
True.
visit and replacing the part. One customer complaint comes means to close the complaint, we have to visit 10 times, like 350 kilometer, 400 kilometer customer location.
And you
So,
remember on day 1 or day 2, I think I have taught all of you certain quality principles.
yes, I remember, sir, I remember.
We all must understand how several elements work together as a system.
Yes, exactly, sir.
The cutting tool used in the machine shop is a key element that ensures, the quality of the products delivered to the customer. Yes or no?
Correct, sir.
So everything, anything can pull down our quality. So everyone should cooperate, and every factor must be attended to, and then only the end result can be great. Just in one department, in one small factor, not handled properly, can lead to a disaster. Possible.
Yes,
Yes.
yes.
Yes. I think few others were raising the hands. Okay.
Sir,
We are good to proceed.
We are manufacturing of lubrication systems with our own design, but we don't have any critical parameters to measure that. So I think so it will help us to satisfy our customer after measuring the critical parameters to and maintain the process in that same level.
Sir, some kind of measurable metrics are required always. Some kind of measurable metrics are required. But I could see you saying that you don't have any measurable parameters. Am I right?
No,
Ah.
no, it is not like that. We have that, but we don't have the critical parameters. No, we have that measurable limits, but the critical parameters are not defined. That is the thing.
So I think you didn't define the process well.
Yeah, correct.
I think you don't have fitment and functional related parameter.
What you are manufacturing, can you tell so that we can do some 2 minutes brainstorming?
Manufacturing of lubrication systems.
So like viscosity is an important parameter.
Flow rate also.
Okay, so
Yeah,
viscosity is
here
if viscosity is
Okay.
less or high, definitely it will be rejected and it will create problem at your customer end.
And 5 plus points.
Yes.
Yeah, very good. Very good brainstorming. Yeah. Sir, definitely, whether your customer gives these kind of parameters or not, it is your responsibility to find out key parameters, monitor, and have a good control over it. Otherwise, in long term, you will miserably fail. Today,
Sir,
everything
I
might.
would like to add one thing here again. Like he told very clearly, his organization is responsible for design. So then customer is not bothered about all these things. If something will happen, customer will go directly to him and he will say, the boss, design is your responsibility and your product is fail. So we are going for the warranty and this is the amount you have to pay. Because when the design responsibilities come with along with the suppliers, it is a completely supplier responsibility because you are the subject matter expert. Customer is not the expert.
Yes.
Otherwise,
maybe after some time they have to recall our product.
Yeah, definitely. So some major failures, we may have to face in a long run. So to avoid that, it is always a good idea to take care of not just the spoken requirement, but also the unspoken requirement. Yes or no?
Correct, sir.
Yes.
Just because your customer did not mention, the what you call the characteristics of the lubricant, what you are manufacturing or lubrication system, what you are designing, it doesn't mean that they will never, ask about it. And definitely, if something goes wrong, yes, they will definitely, will do the blame game. But however, we have to see to that the scenario is win-win. You can try to educate the customer, and then, if he also understand, then it will definitely become a win-win scenario. All right, so let's continue. We will definitely talk in depth as we progress. Right now, let us talk at the outline so that all the participants here are able to follow. That's very, very important. Otherwise, some of them will feel disconnected. So that should not happen.
Correct.
All right. So here the bias is calculated. The bias is also found to be less than 1%. So now you are able to understand how to estimate the measurement error. Clear? So main objective of the measure phase is validating the measurement system and then accurately measure the baseline. And gauge R&R and bias are the terminologies used in measurement system analysis. If you calibrate your measuring instrument, yes, you can eliminate the bias populating from the measurement system itself. But even though you calibrated the bias, your measuring instrument, still there can be a bias in your reading. Yes or no?
Yes.
Now you should blame the measurement system as a whole. And here, only through proper training and standardizing all the procedures, you can keep the the gauge R&R under good control. And then gauge R&R should be less than 10% of the interest zone. The interest zone is normally the customer tolerance, right? But 10 to 30% is conditionally acceptable and more than 30% is unacceptable. Whenever tolerance is not available, Minitab, will perform the study by using the tolerance, by using the variation that is available in the data itself, which is known as study variation, right? But it is always recommended to indicate the tolerance provided by the customer so that you get all the percentage in terms of the customer tolerance. So this is what I would like to discuss with all of you at the initial stage of the measure phase. So now, having ensured that our measurement system is adequate and credible, we are proceeding with the data collection, and now we will try to calculate the baseline performance, right? So there are different metrics of baseline performance: yield, DPMO, and then yield, DPMO, and then CPCPK. And there can be other metrics as well. You all know, we will be discussing, as we progress. Like PPPK is also a good metric of your process capability. And similarly, sigma level is other metric. Some companies use PPM, or you can also create some new metrics, defects per 100 units, defects per 1,000 units, whatever. All of them are ultimately trying to measure your process capability, ability of your process to produce the acceptable products. That is what we call it as capability. So what is traditional yield? Traditional yield, you look at the formula, is nothing but output by input. What is an output? The acceptable products are the output. Yes or no?
Yes.
And the input is nothing but the total produced units. Imagine you produced 100 units. Out of the 100 units, 90 units are acceptable, but 10 units are rejected. Now, what is your yield? 90%. 100 people write the exam and 90 people pass the exam and 10 people do not pass the exam. So what is the yield of your current process? Is 90%. The training effectiveness is 90%.
90%.
Hope all of you understand how to calculate the yield in a very traditional manner. Output divided by input. Right? Let's imagine a banking transaction, a process of banking transaction. Like Google Pay, Phone Pay, so many transactions we do nowadays. Let's say there are 100 transactions happening. Do you think all your transactions are always successful? No. Sometimes, payment is not getting completed. So 90 of 90 transactions initiated by you are successful, but 10 of the 10 transactions are unsuccessful. That means the yield is how much? 90%. All of you, do you understand what is yield here?
Yes.
Clear? This is known as traditional yield. Now I want to introduce another tool, which is known as first pass yield. Now that your current traditional yield is 90%. Now I am asking you, the acceptable outputs are 90%. Are there any output within the 90%, right? Within the 90 units which are accepted? Are there any units undergone any kind of rework? Do you understand my question?
Yes.
Earlier, we only thought about acceptable output. Yes, acceptable 90 out of 100 produced. So yield is 90%. But now, as a manager, I want to know whether any of the parts which are earlier accepted have undergone rework.
5 parts.
8:30. 8:30. So now your operators are telling, sir, 30 units are reworked unit. Within the 90%, within the 90 units we accepted, 30 units are reworked. Now what do you understand? Only 60 of the parts
First
are
time, okay.
produced without any defects in the first run. Isn't it? But
Yes.
other 30 parts, there were some defects happened. Somehow your people reworked on it, corrected it, and they made up the yield to 90%. So the actual effectiveness of your process is only 60%. Because of some additional rework, your people have boosted the effectiveness from 60% to 90%. Can you see that?
Right.
So we should always subtract the reworked quantity to understand the first pass yield or the first time yield. Yes or no? Always we must subtract the reworked quantity to understand the first pass yield or the first time yield. Say, for example, if we conduct the exam, how many of you want to pass the exam in the first attempt itself?
All.
All. That means you all interested in, seeing a greater first time yield. And nobody is interested in, failing in the first attempt and then passing in the second attempt. So reworking is nothing but, passing in the second attempt. Can't you recognize a failure happening there? Yes or no? There is a failure happening. Rework means a defect has happened. Try to prevent that defect. If you are really interested in prevent all the defects at the source, you must monitor first pass yield, not the traditional yield. All of you agree with me on this?
Right.
Yes.
Right. So that's the difference between first pass traditional yield and the first pass yield. And see here, look at the change in the formula here. From the output acceptable unit, I am reducing the reworked quantity. Can you see here? Now my yield will become first pass yield. What we thought as 90% is actually 60% only. Some projects, will focus on improving the FTY. Yes or no?
Correct.
But for the same process, your traditional yield may be 99%. If you have the habit of looking at the traditional yield, you may not understand the opportunity that exists for improvement. But if you have the habit of looking at the first time yield, then you realize, there is enormous scope for improvement. Because 60% is, is quite on the, what do you say, very, very, the scope for the improvement is very high. Clear?
Right.
All right. So the point is first pass yield is definitely better than your traditional yield. And there is one other yield known as rolled throughput yield or simply throughput yield. This is applicable if you are responsible for a compound process. This is applicable if you are responsible for a compound process. You know what is a compound process? Your process are working as a chain.
Yes.
Right? They are interlinked.
Several
output-
processes making one component.
Exactly. The output of your process becomes the input to the next process. See here, there are three processes I am showing. P1, what is the first pass yield for P1? 90%. And now the output from P1 becomes the input to P2. What is the first pass yield here? 80%. Now output from P2 becomes the input to P3. Here the first pass yield is 70%. Now which is the bottleneck process here?
70%.
Yeah, the P3 is the bottleneck. Once you understand the bottleneck yield is 70%, then the overall yield cannot be more than 70%. Can some of you judge how much will be the overall yield here? It will be below 70%?
70% only.
Not 70%. It will be just 50%, 50.4%. This is how much? 50.4%. How do we get the 50.4%? You multiply all the first pass yield. 90.9 into 0.8 into 0.7. 0.9 into 0.8 into 0.7. All of you understand? Because what happens here is, see here, let us imagine you produce 100 units in P1. Out of the 100 units, 90 units are, accepted in the quality check. That is the meaning of 90%. Yes or no?
Correct.
Now the 90 units will become the input to P2. Now what is the yield at P2? 80%. So 80% of the 90 units will come out as the output. Am I right?
Yes.
What is
Yes.
80% of 90?
72.
So the 72 will become input to P3. Now what is 70% of 72?
50.4.
And that is what is appearing.
50.4.
You can either calculate in this manner Or you can simply multiply these three numbers, 0.9 multiplied by 0.8 multiplied by 0.7. So it is 50.4%. So this is known as rolled throughput yield. Ultimately, the overall yield is very important. Yes or no?
Yes.
So every single process should have a higher first pass yield. Then only your overall yield can be higher. If one of the process, if the yield is 0, then overall yield will suddenly drop to 0. Hope all of you understand, right?
Yes.
So this is something to understand with respect to the yield. And we already talked about DPMO. I don't think you have any doubts about calculation of DPMO. Am I right? You will be able to calculate DPMO. So anyway, this is, see here, this example illustrates DPMO can be used, in any industry. See here, a bank is conducting a survey, or bank is, capturing the data from its customer through a survey form. But still, they are always capturing the data with some errors. Either the date of birth name is, date of birth is not mentioned correctly, or name is not mentioned correctly. So ultimately, all of them will appear in the account detail. So they wanted to really bring it down. I mean, really reduce it. So see here, they calculated DPMO for that scenario. So they are floating a form across their customer. The form contains 10 field. They are collecting 10 different information from the customer. That means what is the opportunities for failure here? Number of opportunities are 10.
10.
If the bank asks my date of birth, I can give it, in a wrong manner. First opportunity. Second opportunity, I myself, may indicate my other details in a wrong manner. Maybe my PAN number, there can be a typo error. My name, there can be a typo error. So if there are 10 fields, at the maximum, all 10 can go wrong. This is known as number of opportunities. Now there are 15 people participating in the survey. If 15 people are participating in the survey, what will be the total opportunities? 15 into 10, 150.
150.
Now all 15 people fill up the survey form. Now you open the spreadsheet. In the spreadsheet, you are able to see 22 defects or 22 errors, 22 typo errors, whatever. Now number of defects observed is 22. Now how can I calculate DPMO in this case? First you find out defect per opportunity. Defect per opportunity is defects divided by total opportunity. Defect is 22, total opportunity is 150. So your DPO is 0.146. If DPO is 0.146, then DPMO will be multiplied by 10 power 6. That's all. Nothing but move the decimal by 6 places. Move this dot by 6 decimals. So your DPMO is 1,46,000. Can you see here?
Yeah.
A bank manager, a project team in a bank is able to use DPMO. It's not that all these tools and techniques can only be used in manufacturing. They can be used in any industry, provided you have a good understanding about the tool. Yes or no? So this completes our discussion for the measure phase. But still there are many more to be discussed, like your CPCPK, PPPPK, and gauge order study in detail, and few other MSA like attribute agreement analysis in detail. All that will be covered in the upcoming weeks. So right now the measure phase comes to an end. So we have 2 more minutes to take your questions. If there are any questions which you think can be answered in 2 minutes, please ask.
Sir, can we repeat again about the first pass yield?
First pass yield is nothing but ability of your process to produce acceptable outputs in the first run itself. Nothing but the ability of your process to produce acceptable outputs in the first run itself. Or you want to simplify the definition, it is the ability of your process to produce acceptable outputs without doing any rework.
Okay.
The
Right?
direct to okay part. Direct to okay part.
Direct to okay, exactly.
If I can make 100 kilo material, that all the 100 kilo will be get, and that is the 100%. That is the first pass yield.
100 kilo.
Yeah.
Yeah, you can use anything. You can use numbers, you can use kilogram. I produce 100 kilogram of product and all 100 kilograms are okay, then my yield is 100%. And it is first pass yield. But provided there should not be any rework happening.
So what is the difference between traditional yield and this yield? First pass yield.
First pass yield, see, if there is no rework happening, both are same.
Okay, okay, understand.
But if rework is happening, they are different. Then first pass yield will become better in the sense, better to have a good control over the process.
Okay.
All right, good question. So, shall we take a break here? So,
Okay.
8:30.
Yes, sir.
So, 8:50. See, every day, since we are taking a break, our session is stretching up to 10:15. But I am seeing half of you, running away by 10 o'clock itself. So, you should stay back up to 10:15. So, we will take a break here. To validate, we can measure accurately, then we will be able to validate the problem. Sometimes problem baseline may be more than what we have mentioned in the defined phase. Possible, yes or no? We might thought that rejections are 5%, but the reality rejections may be 8% or 9%. Sometimes problems may not exist at all. People will be simply projecting it as if there is a problem happening always. But reality, there is no problem at all. So what is the issue there? The issue is they don't know how to measure. Good parts are getting rejected, and then bad parts are getting accepted, and these kind of mistakes are happening. So purpose of a measure phase is to validate the measurement system, at the same time get an accurate estimate of the baseline, nothing but the current state of the problem. So anyway, we are done with the measure phase. Now we are going to proceed to the analyze phase. What is our goal in the analyze phase? We already spoke very in detail on day number 2 while talking about y equal to f of x. What is our objective in the analyze phase? We wanted to understand the root causes, not just the symptoms. So there
Sir,
is a
I would like to
structure.
share one example related to the measurement, if you allow.
You want to give one example, huh?
Yes, yes.
Okay, maybe in 2 minutes you can explain.
Yes, a maximum 2 minutes. So we
Yeah.
received customer complaint from our prestigious customer regarding some out of specification dimension. So internally we check everything, but nothing was found. And then we decided to go to the customer end also. Then we do the joint inspection with the customer. Our instrument is also there and customer instrument is also there. So what is the basic difference? Like the customer instrument is not calibrated. Due to that, the error is coming. And the whole production line of the customer is stopped because they are thinking like our components are NG. So this is the importance of measurement. Like if measurement is not good, so the complete direction can go in the other side.
Very good example. Yes. Thank you, Rahul. Okay, now we are going to deep dive into the analyze phase. And now we are going to change our focus from Y to X. So far, we have been focusing on the Y side of the equation. Yes or no? But hereafter, we are going to focus on X side of the equation. Now tell me, when it comes to the X side of the equation, how many X will be there? N number of X will be there. Yes or no?
Yes.
First, you make a sincere attempt. Make a sincere attempt to list all possible X factors. Create a list of all possible X factors. This is what you will be doing in the fishbone analysis. Yes or no? In fishbone analysis, you try to visualize all the X variables, all the X factors. Does it mean all the X factors are root causes? No.
No.
Not necessarily. Yeah.
No, not necessarily. Only few of the X factors are currently troubling your Y variable. In the current condition, please note, in the current condition, which are the X factors that trouble my Y variable? Very, very important line is in the current condition. The current condition, because all the X factor, might be able to influence your Y. That is very, very true. But in the current condition, which are the X factor actually troubling your Y? Those X factors are known as critical right now. Yes or no? Those X factors are known as critical right now. And those critical factors can be declared as the root causes if you can prove the criticality. Those critical factors can be declared the root causes if you can prove the criticality. Proving means data should also confirm the same. Data should confirm that in the current operating range, the data should confirm that the current operating range of the X variable is not suitable for the Y. Do you understand? The current range of operation for the X variable is harmful to your Y. If you can prove this, the factor can be declared as root cause. This exercise is known as root cause validation. In statistics, we call it as hypothesis testing. We are not going to discuss hypothesis testing in detail, but however, you should know that, right? But how can we slowly, move towards the root causes? Imagine a crime has happened. Somehow we have to catch hold of the criminal. A crime has happened. Somehow we need to catch hold of the criminal. So what do? First, we create a list of all, all who would have involved in the crime. Yes or no? This is known as possible. This is known as possible causes. They're known as possible causes or probable causes. Then, out of so many suspect criminals, what we do is we figure out some strongly suspected criminals, isn't it? And then we will perform a detailed investigation. Let me put it other way. Let's say there is a party hall where a party is happening. There are about 200 people attended the party. And the family conducting the party, they have kept some valuables in a room. Valuables worth about 50 lakhs. But all of a sudden, they have found the valuables are missing in the room. A big crime has happened. Yes or no? And now, if we are all definitely the family member, family will be interested in finding out the criminal. But who have attended the party? Your own friends, family members, right? And certain distant relatives, distant friends, all are there. Now it's very important you create a list of all the people who attended the function. Yes or no? If you are really interested in finding out your 50 lakhs, you have to create a list of all those who attended the party. Yes or no?
Yes.
Right.
This is the objective of drawing a fishbone diagram. If you don't do this, properly, some of the members might escape through the back door. Yes or no? So first thing you need to do is the moment you realize, yes, something is missing, you should immediately close all the doors. Then create a list of everyone present in the room. Because you very well know that definitely the criminal is within the list. So your fishbone diagram should be able to capture all possible X factor. If you are missing, definitely you might have allowed the root cause to escape from your vision.
Correct.
Clear?
Correct.
So please conduct enough brainstorming. Ask everyone's opinion. Don't discourage anyone during the brainstorming session. allow everyone to speak. Even the operators can also express their views. Allow everyone to speak and create a complete list. That is the main purpose. And now that you have a list of 500 people, but still you have not recovered your valuables. Now what will you do? You will try to take the support of the experts. The experts are nothing but the police people, right? You will call the police and they come to the hall now. You know what they will do? They will try to collect the available information on the spot. Which room the valuables were placed, who were given the access to the room, who were sitting close to the room, are there any CCTV footage of the room, who was holding the key. Some logical questions can throw light, yes or no?
Correct.
If you throw such logical questions for the involvement of the experts in the process, you will be able to narrow down the list of 200 to a list of 20 or 30. Yes or no? So now the list of 20 or 30 is known as potential causes. Because investigating all 200 is not feasible. Police cannot investigate everyone. Police cannot take everyone to station. But definitely taking 20 people to the police station is possible. Am I right?
Correct.
They can call these 20 people to the police station and you know how the investigation will be at their place. They will try to do everything to extract the fact. Yes or no?
Correct.
You should also become vigilant and ruthless while conducting the root cause analysis. Once initially, yes, possible causes, then potential root causes. But once you are able to figure out the potential root causes, then you must be completely fact-driven, data-driven. Agreed?
Correct.
And the steps involved in validating the potential causes and declaring some of them as root causes. What is the name I told you? That is hypothesis testing. Hypothesis testing. You refer to the data or perform experiments purposefully and generate the data and try to understand the information coming from the data. Already your doubt is factor is a root cause. Now information coming from the data is also confirming that the factor is the root cause. That means your suspect is correct. You can declare the factor as one of the root cause. You should also try to understand. So out of the 30 people, police found, 2 people or the criminals involved. But how much money we kept there? The valuables worth is 50 lakhs. Now these 2 people are telling that each one has got 30 lakhs. Each one has got, let's say, 15 lakhs. So what is the total you are now able to recover? 30 lakhs out of 50 lakhs.
50 lakhs.
That means 60% of the loss you are able to recover. You detected 2 criminals, but still 40% you have not found. That means there is a chance that few more criminals are involved. Yes or no?
Yes.
Similarly, when you declare root causes, you should ask the same question to yourself. What is the percentage contribution of each of these root causes? How much influence is coming from each root cause? So what is the total influence? The total influence should at least be 80% and above. If it is 100%, you have found everything. Isn't it?
Correct, sir.
If you are able to recover all 50 lakhs, that means 100% valuables recovered. The problem is completely solved. But in an industrial context, at least 80% of the influence you must be able to understand. Or at least 80% of the root causes you should be able to understand. If you are able to reach 80%, you have done a good job in the analysis space, in the analyze space. Clear, all of you? Otherwise, your job is not sufficient enough. You may see improvement, but still it's not sufficient enough to solve the problem in the required extent. Clear? So what is the tool we can use to figure out how many root causes are involved? What is the tool to figure out how much contribution is coming from each of the factor? The name of the tool is regression analysis. And definitely this is a tool for the black belts. The name of the tool is regression analysis. In order to perform regression analysis, high quality data is required. In order to perform regression analysis, high quality data is required. The data which is free from experimental error, the data which is free from what you call the sampling error, measurement error, sampling error, and you must definitely have a high quality data at the same time in required quantity. High quality data in required quantity, which is possible if you conduct the experiment in a systematically planned manner. Systematically planning your experiment and conducting the experiment and consciously controlling the error is known as design of experiments. Consciously controlling the error is known as design of experiment. That means I want to see all of you as a very good researcher in your field. Isn't it? One who is performing the experiment by consciously controlling all sources of error. All sources of error. There can be measurement error. There can be effect coming from uncontrollable factors. There can be effect coming from controllable factors. Ultimately, we are going to take actions on the controllable factors. So you should be able to figure out the effect, separately. And hence, you will be able to see, you will be able to frame a mathematical equation. You remember day number 2, I have discussed y equal to f of x. Now is the time you can see the equation in a complete shape. Now is the time you can see the equation in complete shape. All the root causes will appear as x factors on the right side. All the root causes will appear as x factors on the right side. Suppose if there are 3 root causes, in your equation, how many x will appear? X1 will appear, x2 will appear, x3 will appear. All the other factors are not critical right now. Yes or no?
Correct.
Yes.
Yes.
But other factors are also producing the result, are also allowing you to produce the result. But those results are stable. That's all right. So you will just add a constant term. You will add a constant term. So I will now write it for you. So now I write an equation. You see here in the context of, let's say there are 3 equations. 3 root causes. Can you see my equation now? This is the condition of my process right now. This is the condition of my process right now. X1 is a critical factor and X2 is another critical factor. X3 is another critical factor and all other factors are not damaging my result. But however, some output is coming because of the other factors also, isn't it? So I add a constant term. Even if these, X1, X2, X3 are not playing any role, or if I remove all the X1, X2, X3, still my Y will, have certain, result. That is a constant term. So now I should find a way to ensure the X1, X2, X3, all of them are now moved to a new location. All right. My X1 in the current condition is operating between these points. Right. So X1, let's say X1 lower value and X1 lower upper. But what is our finding? This range is not suitable for X1. Am I right? This range is not suitable for X1.
X1.
Yeah, your X1 can vary. Let's say your boiler is running between 600 degrees Celsius to 1000 degrees Celsius. Now you find that the running temperature is the culprit. Boiler running temperature is the culprit. So 600 to 1000 degrees Celsius is not good for your boiler efficiency. That is the conclusion. Yes or no?
Yes.
Now, the solution may be reducing the range to, let's say, 800 to 850 degrees Celsius. Solution may be reducing the operating range from 600 to 1000 to 800 to 850. Or changing the operating range to a new location. I don't know. It may be, let's say it is 1100 to 1150. Possible. So, this kind of changes we need to effect. But in order to think in this direction, you might require to understand the regression equation. Yes or no? You identify the root cause,
Regression equation.
validate the root cause, then for every factor x1, how it is related to y1. Is it related positively or is it related negatively? What is x1? The boiler temperature. What is y1? The efficiency of the boiler. I want more efficiency. Isn't it? So it's very important I understand the relationship. The moment I understand boiler temperature and efficiency are positively related. What do I mean by positively related? More the temperature, more the efficiency. Negatively related means more the temperature,
Less the temperature,
lesser the
less the
efficiency.
less the.
If there is only one kind of relationship exists, it is known as linear relationship. If the relationship can also be dynamic. That means in a particular range, it is positively related. And suddenly after that, it is negatively related. Now, can you see the relationship becoming dynamic now? This is what we call it as non-linear relationship. All of these things you will be able to understand by performing a designed experiment and framing the regression analysis. Right? So I have told you, what kind of tools you need to learn, but however, we'll slowly master these things. Now we will focus on the other tools, the simple tools which we normally use in analyze phase. And then if we use, but those tools are also equally powerful because only those simple tools will take you to the level of hypothesis testing and level of design of experiments. Yes or no? If you don't know how to conduct the brainstorming, don't know how to create the fishbone diagram, don't know how to narrow down a bigger list into a smaller list, if you make mistakes there, all your efforts during the hypothesis testing and design of experiments can also go wrong. Yes or no? So it's very important that you perform all the steps in a very effective manner. Okay. So now let's quickly finish off the activities that are happening in the analyze space, tollgate review, steps and deliverable, and the tools. Have you identified the sources of variation if it is a Six Sigma project? Have you identified the sources of waste if it is a lean project? Have you identified the potential failure modes if it is a risk mitigation project? All right. Have you listed all possible X factors? What kind of tool we use normally to list all possible X factors? Fishbone diagram.
Fishbone diagram.
Fishbone diagram. Have you identified the potential X factor from the potential X factors? I mean the critical ones, right? From the list of big list to a narrowed list. Yeah, potential X factor or the critical X factors. And then, have you statistically validated the root cause? Do you have any data evidence to declare that a particular factor is the root cause? Very simple. That's the question. If you do not have data, it's everything is a gut feeling, then you can be correct also, you can be wrong also. We don't know. But if you also have a data evidence, almost close to 100% you are correct. Only a smaller amount of risk might exist. Yes or no?
Yes, sir.
If you have data, you will also be able to declare your confidence level while declaring any statement. Normally, the expectation is you must declare with 95% confidence. That means the amount of risk involved in your declaration is less than 5%. Correct?
Root cause validation can be done with the help of this regression analysis as well, and through hypothesis testing also, right, sir?
No. The purpose of regression analysis is different. Hypothesis testing is, in fact, strictly speaking, your regression analysis is also a form of hypothesis testing. But before regression analysis, you perform hypothesis testing. There are other methods, other hypothesis testing like your ANOVA, one sample G test, one sample T test, chi-square test. And these tests you need to perform to validate the root causes. After identifying all the validated root causes, you proceed to the regression analysis.
So both the things are telling that how my cause is relevant to the why, how strongly it is relevant to the my why.
Yeah, correct. That's what I told you. What is the contribution of each factor for the current problem? Currently, your Y is fluctuating. Your Y is, trying to move away from the target. I mean, your Y is moving away from the target. How much movement is because of X1? How much movement is because of X2? And how much movement is because of X3? That is your question, yes or no? The answer can only come from regression analysis. The answer can only come from regression analysis. Anyway, so have you statistically validated the root cause? And then, are the validated factors sufficient to produce the result? Are the validated factors sufficient to produce the result? That means what is the total contribution? I told you, you remember, total contribution should be 80% or above.
80% of
So that you
Minimum
can
80%.
confidently close your analysis and proceed to the solution generation activity. So list possible X, then identify and validate the root cause, then verify the sufficiency of the factor. The main deliverable is validated root causes. And listing the possible X factors, brainstorming, YY analysis, cause and effect analysis, cause and effect diagram. And then for validation of, for identification of potentially critical factors, and then validation of the critical factors, you can think about using impact control matrix or cause and effect matrix. Or both of them, serve the same purpose. Then these are the terminologies you need to understand, which we'll be discussing you a little later. Like your what is null hypothesis, alternate hypothesis. This is definitely taught at the green belt level. Type 1 error, type 2 error, probability of significance, test of averages, test of proportion. And then in order to understand the sufficiency, correlation and regression analysis. This correlation, we will see a overview today. All right. All of you understand how the analysis should go? Analysis, now please understand, analysis is not just about drawing a fishbone diagram. That is only a beginning of the analysis. All right. So objective of the analyze phase is to identify and validate the root cause, list all possible X using brainstorming, fishbone diagram, and YY analysis. Then narrow down the list, either using a Pareto analysis or using an impact control matrix or using a cause and effect matrix. It all depends on your ability to use the tool. You can even use a Pareto and then still do this job, right? And then formulate an hypothesis and then try to validate your claim, right? Claim about the root cause. Then again, verify the sufficiency of the factors using regression analysis. You got the picture of analysis, analyze activities? Yes. And I don't have to actually teach you how to create a fishbone diagram and other things because you're all experts in that already. Yes or no?
Yes,
But the important point to understand in the while creating the fishbone diagram is don't miss out on any of the factor. Normally we have a tendency to only list down whatever comes to our mind. Actually, the idea should be to list all the X factors. You can also categorize them, nothing wrong. You can categorize them under, men, machine, material, method, measurement, mother nature. Or you want to change the name of the categories according to your interest? Yes, absolutely okay. But do it in a meaningful manner, logical manner. Suppose if I am working on improving the training effectiveness of the program, then I will also create a fishbone diagram. How our effectiveness is getting down, or what are the factors that can influence our training effectiveness. So now my categorization will be trainer related factors, course material related factors, exam related factors, participant related factors. Yes or no? So now my pillars are different. My categorization style is different. It need not be always 6M. Do it in a very logical manner, and then you will be able to handle the factors properly. Clear? There can be 6 factors. I mean 6 categories. There can be 4 categories. There can be just 2 categories. Whatever way, as long as you are able to solve the problem and fix the problem, it is absolutely okay. Okay. So now let's try to understand our the possible X factors tools. So brainstorming, Y-way analysis, cause and effect analysis, impact control matrix. So what is brainstorming? You call all the relevant stakeholders to participate in the meeting, isn't it? Now it is very important you call the people who are really interested in solving the problem, not everyone. If somebody is not really motivated to participate in your project, first you try to motivate them before inviting them for the discussion, before allowing them to participate in your project, right? So a little bit of stakeholder analysis, stakeholder management is important so that all of them can really contribute in solving the problem. So brainstorming can be structured, brainstorming can be unstructured. If there are no rules, no guidelines to be followed during the brainstorming session, the session is known as unstructured. If you have some set of guidelines, only in that manner the brainstorming should happen. Then the brainstorming is known as structured brainstorming. Each one will have a plus and minus, yes or no?
Yes.
If I say everybody should talk, then it may be sometimes, what to say. Some people might hesitate to talk. At the same time, if I allow no interested people to talk, only 1 or 2 fellow will be talking in the whole meeting. So both will have a plus and minus. You need to understand which can work well for you. Ultimately, our idea is to identify and create a list of all possible X factors. Whichever works, use that. Or you want to use combination of both? No problem. You can decide and do it. All of you understand? Now, why analysis? What is why analysis? You ask the question why again and again. Then what will happen? You can use the why analysis for solution generation also, for root cause analysis also. In root cause analysis, this tool will help you to peel away the layers of symptoms. Take you to the layer of the root causes. Because initially people will only talk about symptoms. You have to actually make them go deeper and deeper by asking the question why. Then after 2-3 rounds, or sometimes 4th or 5th round, you will be able to understand, yes, they are now really talking about the causes, right? So that is the advantage of Y-way analysis. It is actually developed by Sakichi Toyoto. But however, it gained the popularity only in late 1970s. So let's see a small example. Can one of you help me read the question and the answer? Or see here, I will tell the problem and then I will ask the question. Then you can read the answer. See here, the problem is one of the monument in India is deteriorating, is losing its shine. So the maintenance team wanted to do a conductor analysis. Now they decided to use Y-way analysis. Now the first why. Why is the monument deteriorating? And who can help me by reading the answer for this question? Come on, one of you can read out louder.
Because harsh chemicals are frequently used to clean the monument.
Oh, great. So now I understand you are saying that harsh chemicals are used. Now I want to proceed with the next why. Why are harsh chemicals needed?
To
Come
To
on.
clean up the large number of bird droppings on the monument.
Oh, you want to clean up the large number of bird droppings on the monument. Now, why are there large number of bird droppings on the monument?
Because the large populations in and around the monument are because of the
So there
local.
is large population of spiders. And please tell me, why is there a large population of spiders, particularly in and around the monument? Come on.
Improper closing of
Yeah, here answer is here. You can just read out this.
Because vast swarms of insects on which the spiders' feet are drawn to the monument at dusk.
Yeah, because there is vast swarm of insects. So to eat the insects, spiders are also attracted. So my next question is, why are large swarms of insects drawn to the monument at dusk?
Because of the lightning of the monuments is the evening attracts the local insects.
Oh, now an actionable point is coming. Can you see that? So you have too much of lightings.
Hello.
Maybe you are also switching on the lightings earlier. As a result, too many insects are getting attracted. Since insects are getting attracted, spiders are coming. Since spiders are coming, birds are coming. Since birds are coming, bird droppings are happening. Look at the source of the problem and look at the root cause now. We never thought that lighting can be a root of the problem, isn't it?
Yeah.
But after collecting, this informations with the help of the YY analysis, we are able to understand, yes, the way monument is illuminated
Sir,
could also
here
be
I
the
have one
reason.
doubt, sir.
Oh, sure, please.
Sir, I'm Srinivas. I'm working in a pharmaceutical organization. So sometimes during evaluation, by using 5-way analysis tool, if we will get sometimes we get an answer with the 3-way also.
Correct.
So at the time, shall I close that shall I conclude with the 3-way also, or need to make it with the 5-way?
No, you are correct. You can stop at third way also.
But,
Sometimes you may have to go beyond fifth way also. It's
Yes,
all
yes,
absolutely fine.
But sometimes you got an answer with a 3-way, but as per internal policy, they said 5-way, we mentioned that a tool. So at the time, is it required to make it in the 5 or not required to?
Policy and all not required for this. Yeah.
Right, sir. Thank you. And one
Purpose
more
is
thing, sir,
not-
during root cause analysis, if we can get, by using fishbone analysis, we can shortlisted by multiple root causes. At the time also, for the impact analysis also, you need to be apply that fishbone to evaluate all the.
Yeah, that's coming. That's coming in the next slide.
Right.
So now that we understood, see, you can always think, actually, you need to use, the combination of all these tools. There will be brainstorming happening. There will be brainstorming happening. At the same time, you can create a fishbone diagram, isn't it? At the same time, there can be a YY analysis happening. All that can happen, right? So this is another example I don't want to read out, right? You can, there are hundreds of examples available. A fishbone diagram, also known as cause and effect diagram, also known as Ishikawa diagram. And fishbone diagram is listed as one of the 7 basic quality control tool, right? So here there is a fishbone diagram created to study a particular problem. The problem is, what is the problem? Obesity. Hope all of you can easily figure out the possible factors for obesity. Yes or no? We all know what is obesity, right? So if the problem is understood properly, yes, definitely no. We can list down all X factor. So what could be the reason for obesity? Eating junk foods, not sleeping well, not exercising, right? Maybe stress, maybe hereditary reason. So many things, right? So we just have to list down everything. See here, we are actually listing. So we are able to list everything, so many things. But here 6M is used, as I already told. You can also, change the category titles according to your convenience. And see here, make sure you catch hold of, all the possible X factors. And then what can you do? Now imagine, put yourself in this scenario. Imagine you are right now obese. Will you be able to suspect on some of these factors? Because you know your experience, yes or no? See, what is written is a general diagram. This general diagram is applicable for everyone. But right now, I want to solve this problem for myself. I very well know what kind of habits I have developed. I don't exercise. So what will I do? I will put a round mark here. Why am I putting a round mark? Because I myself know I am not regularly exercising. I will also put round mark in some other area. I have the habit of eating fast foods. All right. And I also have the habit of drinking aerated drinks. You understand? And I also doubt I travel, maybe, maybe yes. I don't play any games. This is also, I don't normally play any reduced, no outdoor gaming. So likewise, you need to round down. You can you can also select certain factors for conducting the investigation at the next level. You may be correct, you may be wrong, but more chances are there for you to be correct. All of you agree with me? If needed, you take some doctor's advice also, some dietitian advice. Take the inputs from your wife. All of them are stakeholders. They're all interested in, seeing to that the problem is solved. Yes or no? So involve all the stakeholders, subject matter experts, and while doing this exercise, and also you want to create some record, some evidence of, doing this in a systematic manner. You can think of using what? An impact control matrix. So this is another example for fishbone diagram. What is the problem we are trying to solve here? The problem should always be written on the head of the fish. The problem should always be written on the head of the fish. You see, this is your Y. Yes or no? That is your Y. And all these things, what you see here are the X. All right. So here, there is a mistake here. Can somebody tell me what is the mistake here in this fishbone diagram?
The arrow marks
Arrow
are
marks?
pointing towards the elements of the input. It
So
should
you
be
mean to say these things?
The problem is not specific.
Very good. Very good. The problem is not specific. See here, too many things are written here. Can you see that?
Yeah.
Avoid doing this kind of mistakes, right? Try to develop a separate fishbone diagram for each problem. That's very, very important, right? So otherwise, it's fine. And now you can actually round off certain suspect factors and take it to the hypothesis testing, or you want to do it using this impact control matrix. This is also okay. You see here in impact control matrix, how many quadrants are available? 4 quadrants. What is this red quadrant? High impact, high control. Both are plus, right? Double plus. High impact, high control. High impact, high control. And here, low impact, low control. But here, impact is high, but control is low. And here, impact is low, but control is high. So what you need to do is you just have to segregate your factors one by one according to this criteria. Segregate your factors one by one according to this criteria, and then try to understand what are the factors that appear in this region. whatever factors appears in the high impact, high control, yes, they will be taken to the next level, right? For root cause validation. And let's see whether we are able to do this. And now tell me, now let us take one case here. Delayed delivery. Now for delayed delivery, tell me wrong packing material. Do you think this is responsible for the delayed delivery?
No.
So there is no impact, and this is a low impact, I would say. The impact is low impact. And how about the controllability? Impact wise, it is low. I can change the packing material. Yes or no? I have the powers to change the packing material. So control is high. I would say low impact and high control. So which quadrant this factor will go now?
The fourth one.
Yeah, the fourth one. So let us see that fourth one. So low impact, high control, and packing material will come here. Am I right? Yes or no?
Yes, sir.
Packing material has come here. In this manner, you have to continue the analysis for every item. See here, wrong product received from the supplier. Wrong product received from the supplier. Now tell me, is it high impact factor or low impact factor?
Low impact.
High impact.
High
High
impact.
impact.
Now some of you are able to feel like high impact factor, and some of you are feeling like it's a low impact factor. Both of you are correct, because the situation only decides whether it is a high impact factor or low impact factor, isn't it? If very frequently my suppliers are supplying a wrong product, then I am replacing the product, then it is a high impact. Yes or no? Because they are doing the mistake very frequently. All right. So both answers can be correct. So you have to categorize accordingly every factor. And then what are the other factors? Let's say, let's say uh, quality estimation of delivery time. Quality estimation of delivery time. Your customer support making a wrong commitment about the delivery of the item. That is also needs to be considered. So in fact, you will be able to better classify the factors if you put yourself completely in the real-time scenario. Yes or no?
Yes.
And if you actually put yourself in the real-time scenario, a high impact factor might go to low impact category. Similarly, a low impact category might come to high impact category. It's all possible. There is no standard rule that a factor should always appear in a high impact category. No. In real time, what is exactly happening, that must be mentioned, right? So in this manner, you will be able to categorize the factors, and whichever factor that appear on the high impact, high control quadrant, all of them must be considered for a detailed investigation known as hypothesis testing. Or otherwise, whatever factors that appear here, they are known as potential root causes. Clear? Clear, all of you? Use
Yeah, clear.
brainstorming, analysis, cause and effect diagram, or
Sir?
combination of all of this. Yeah, please.
Sir, is there any criteria to select the tool for the against the problem or any discrepancy?
So that's
Now, what
what
are the categories we are need to be evaluated for before selection of the tool against the discrepancy? Is it required to select every time fishbone or YY also is
Yeah,
there
it is better to use fishbone every time.
for every?
Fishbone is a beautiful tool. We can use it in all projects.
So there is no any
Normally,
criteria
in
for
any
the
DMAC project, in the analysis space, And fishbone diagram is mandatory.
Okay, sir.
Right?
Thank you, sir.
Yeah. Good. Are we good so far, all of you?
Yes, sir.
Yes, sir. Yes, sir.
Sir,
Yes.
sir, I have one question.
Yeah, please.
Can we go to the impact matrix again?
Yes.
Sir, you said that if whatever comes in the first, we have to take these causes to the next level. But my question is, if there is some causes are coming which has very high impact, but I do not have any kind of control on it, then I think we should work on.
Yeah. So you think that the factor is, currently influencing your result, but still you don't have control over it.
Right, sir.
What will you do in a real life if you come across that such scenario?
In that case, I will work towards it to make some kind of control on it.
We'll wait for the time to favor you, yes or no? There are many
Yes,
situations you are not
sometime.
able to talk against your own spouse.
Yeah.
You just, you will wait patiently for the time to come, yes or no? So because
Right.
you lag in terms of control. Let's say you want to buy a new machine because the machine condition is very bad right now, but your management do not have any budget. What will you do?
Okay, so I understood, sir. The context.
Good. So because right now there is something else which you can work on. So that is appearing in high impact, high control quadrant.
Right.
But the moment you realize your control has now enhanced, you can bring that into that quadrant and start working on it. Yes or no? The same management
Right.
might offer a budget later on after 2 months. That time this factor will come to your first quadrant.
Right.
So that's what I told you. The current conditions, understanding the current condition is very, very important. If
So
we
in that
work in
case,
isolation, yeah.
so in that case, we can conclude that if there is a high impact on any kind of causes, at the same time, if we have the sufficient amount of control, then we can work on it. We should prioritize that only on the first place.
Correct.
Okay, sir. Thank you.
All right, good. So I wanted to give you a little understanding about a statistical tool known as scatter and correlation analysis, right? Scatter analysis and correlation analysis. The purpose of performing scatter analysis and correlation analysis is to understand the form of relationship. Form of relationship means whether the relationship is linear or non-linear. I already spoke about this, right? Linear means the relationship is stable. Linear means the relationship is stable. Positive remains positive. Negative remains negative. That is linear. If the relationship changes from positive to negative or negative to positive or keeps on changing, then the relationship is non-linear. So scatter analysis can help you to understand the form of relationship, right? And then correlation analysis can help you to quantify the strength of linear relationship. Can help you to quantify the strength of linear relationship. If the relationship is linear, then you can quantify how strong it is or how weak it is. So that's what we are going to understand here. So what is correlation analysis? We'll also see scatter diagram as part of it. And then terms used in the, correlation, and then few cases we'll see. And see, now I'm showing you a diagram here. This is nothing but what do you call a graph showing the relationship between your x variable and y variable. In order to plot a scatter diagram, both your x variable and y variable must be of continuous nature, continuous variable. Clear, all of you? X and Y. For example, the speed of your vehicle and the mileage of your vehicle. Both of them are measurable. Both of them are continuous. I'm trying to understand whether the speed and mileage are related to each other. If I drive my car, at a higher speed, probably I may lose mileage or I may gain mileage, which I want to understand. So what I do is I run my car at different speed. At every speed, I also measure the mileage of the car and then visualize it or plot it in a graph. The resulting graph is known as scatter plot. Are you able to see a scatter plot here? The X variable is known as predictor variable and the Y variable is known as response variable. Terminology, same input output only, but we call X variable as predictor variable and Y variable as response variable. Now look at the way your points are getting, visualized. Are you able to see some pattern here?
Yeah.
What is the pattern? The points are forming tending to form a straight line. That means the relationship is linear. Relationship is linear. Because this knowledge is important to perform the regression analysis later on. This knowledge is important to perform the regression analysis later on. Moreover, I see all the points lying on a perfect straight line. So relationship is not only linear, it is a perfect linear relationship. Clear? Over and above, I could understand whenever my X variable is increasing, I am able to notice my Y variable is also increasing. Whenever my X is increasing, can you see where Y is also increasing? When my X is moving from here to here, my Y is also moving from here to here. When I move my X from here to by a longer distance, my Y is also moving by a longer distance. So this is known as positive relationship. Like adding a sugar in your coffee and your coffee becoming more and more sweeter. More sugar, more sweeter. Relationship is positive. So if the relationship is already known to you, feel good about it, feel proud about it. But if the relationship is not known, merely performing an experiment can allow you to understand the relationship. Yes or no?
Yes.
Very good. So now the next one. This is strong positive. In fact, I should say perfect positive because it is perfect line. Now, what do you understand about this relationship?
Negative.
Negative, but strong or perfect.
It is
Better to
again
use the
linear
word.
negative.
Very good. Linear, negative, perfect correlation. All these words you can use. Even I am wrong here. I have mentioned strong. The better word is perfect. Why perfect? It's a perfect straight line. If you keep a scale and draw it, you will see all the point lying on the line. Yes or no? The line you are able to draw is nothing but the regression line. The line you are drawing by connecting all the points is known as the regression line. Finally, we are interested in writing down the mathematical equation of the line. That mathematical equation is the regression line. Okay. Anyway, we'll slowly develop our understanding. So, third one. Now, what is your observation here? Are you
No
able to?
correlation.
There is no correlation.
Oh, there is no correlation, and in fact, there is no relation also. No correlation. I don't see linear relationship. I am also not able to see even any non-linear relationship. Yes or no?
Yes.
Very good. So, scatter diagram gives you, the initial information about the relationship. And now I am showing you a diagram. You see here, there is a diagram. This is a scatter diagram. Now look at the points here, blue color dots. Now tell me what kind of relationship it is.
It is a positive relationship.
Linear positive correlation.
Very good. It is positive. It is linear. I appreciate both the answers. Very good. Linear, positive. What else you can say? Is it strong? Is it perfect?
Strong linear.
Strong perfect.
It's not
Strong,
perfect.
not perfect. Not
Not
perfect.
perfect.
If I give you a
with
coffee, you
certain,
can
certain
immediately say
limitation
whether the
range.
coffee is strong or not, isn't it? But instead of coffee, I'm giving you a scatter diagram. And you have to find out whether it is exhibiting a strong relationship or not. But definitely this is not perfect because the points are not on the line. Isn't it? They moved away by a small distance. So you can call it strong. You can call it strong. But problem is, if the definition is not very clear, people will tend to will say this is weak, yes or no? So to overcome that difficulty, a formula is developed by a statistician known as Pearson. According to him, this is the formula, Pearson correlation coefficient. Look here. What is it using? It is using your data, the data of X and Y. Average of the X is available, average of the Y is available, standard deviation of the X is used, standard deviation of the Y is used, number of sample is used. With all of this thing, he is able to calculate a coefficient which he named it as regression, which he named it as correlation coefficient. The formula is designed in a way that this coefficient can range between -1 and +1. -1 and +1. So the center value will be what? 0. If the correlation becomes 0, it confirms that there is no relationship. For example, you know how the no relationship scenario will be. For this graph, for this data, if you calculate correlation coefficient, what will be the value you will get?
0.
You will get value 0 or closer to 0. So 0 or closer to 0 means no relationship. But if you get around 1, then the relationship can be strong or perfect. And 0 to +1 is positive relation, 0 to -1 is negative relation. And within the positive and negative side, up to 0.4 is known as weak relation. 0.4 to 0.7 is moderate relation. 0.7 to 1 is strong relation. Exactly 1 is perfect relation.
Perfect.
Hereafter, if you have the correlation coefficient, you will be able to use all these words properly. Yes or no? All of you can give a consistent conclusion. You cannot, no, you will not differ from each other, which is very, very important in any project. So this is the formula. Don't worry about all the formulas, but you can definitely perform correlation analysis. Now tell me, look at this graph and tell me what is the kind of relationship.
Linear.
Strong.
Linear is strong.
Linear.
Wrong?
Strong and positive relation.
Very good. Strong and positive. Fantastic. Look at the number correlation coefficient here, 0.917. Can you see that? And now tell me what is this relationship?
Strong.
Negative.
Negative.
Negative linear.
Very good. Strong negative relationship. Now what is this?
Scattered negative.
No relation.
Negative neighbor.
Positive weak relation.
It's weak
Relation.
Weak
positive.
positive.
Weak positive relation.
Positive relation.
Very good. Weak positive. And this is weak
Negative.
Negative.
weak negative. Weak positive. Now
No correlation.
No
correlation.
no correlation. No relation. Now
Non-linear.
yeah, non-linear. So
Non-linear.
you can definitely say no correlation because correlation refers to linear relationship. There is no linearity. But what are you seeing? You are seeing non-linearity. Right? So there is no correlation, but but there is still a relation. Do you understand?
Correct.
The factors are not linearly related, but they are non-linearly related. In this direction, there is a negative relationship. Afterwards, it is positive relationship. This kind of curve is known as parabola.
Parabola.
Yes.
Parabola, right? A quadratic relationship. Okay, you will, and this piece of information will be helpful in writing down your regression equation in a correct manner. So scatter plot is a graphical tool used to examine the relationship between two continuous variables. Correlation analysis is a statistical technique to measure the strength and direction of linear relationship associated between two continuous variables. Pearson correlation coefficient is a measure of strength of linear relationship between two continuous variables. Correlation coefficient can range from -1 to +1. Positive values indicate positive relationship, negative value indicate negative relationship. Values closer to indicates weak or dubious relationship, but values closer to 1 indicate strong or perfect relationship. Do you think this information will be helpful in your analysis?
Yes.
How it will be helpful? If you know strong positive relationship, what will be your approach then? Strong relationship means what? The influence is higher.
Higher.
Whatever R value comes, let us say R equal to 0.8. 0.8 is strong, yes or no?
Yeah.
Now, how much influence is coming from this factor? How much contribution this factor has got on the effect, on the impact? Can you multiply 0.8 or can you square the 0.8? If you square 0.8, what will happen? What will be the value, resulting value?
0.64.
0.64. That means 64% effect is coming from that factor. How did we get this 64? By squaring the R. So R square is the tool. When I square my R is correlation coefficient. But when I square it, it is known as coefficient of determination. The coefficient of determination can help me to understand the contribution that is coming from the factor or how much influence the factor has got. The factor has got 64% influence, which means 64% of the problems I see in my Y are caused by the variations I am seeing in my X. Very simple. According to the experiment, please note. That is why your experiment should be performed in the current condition of your process. Do you understand? Your experiment must be performed in the current condition of your process. You are running the boiler with the operating temperature of 600 to 1000 degrees Celsius. So your experiment should also be conducted in the same range. Then only your R square, everything, will give meaningful conclusion. Okay, that's all I wanted to share with you about the analysis space. But definitely we will deep dive. Definitely we'll deep dive and understand more in the upcoming sessions. Clear, all of you?
Yes, sir. One point. So here this
yes.
Pearson correlation coefficient, that is R. So regression also same only, sir. So R square.
No, in regression, we call it as regression coefficient. In regression, we call it as regression coefficient.
Calculation method is different, sir?
Yeah, slightly different. But please note, if there is only one factor, if there is only one critical factor, right? If your process is influenced by only one factor, your correlation analysis and regression analysis will lead to same conclusion.
Okay, understood.
But if there are more than one factor, then only your regression analysis can speak better.
Better than this or Pearson correlation coefficient. Right.
Yeah,
Understood.
your regression analysis can speak better than correlation analysis. And there are certain reasons behind. which we will educate you in the upcoming sessions. Okay?
Okay, sir. Understood.
Okay. Hope all of you understand your responsibility while performing the analysis, right? So the improve and control, we still have 15 to 20 minutes. Don't worry. It's a very lighter content compared to define, measure, and analysis. Because if you define well, measure well, and analyze well, then improve and control is merely a formality. Yes or no? You do all of these things properly, then improve and control is merely a formality. You only need the support of people around you. Because you now understood everything. All that required is, your own project team members and your own boss, your own management should support you. That's all. So you will affect the improvement, and then, you will find ways to sustain the improvement. So improve phase. Again, improve phase tollgate review, steps and deliverables, improve phase tools. See here, these are the questions you should be able to answer at the end of the improve phase. How did you generate the past solutions? If you propose something, definitely, the management will be asking this question. On what basis you are recommending the solution? What are the tools you have used in generating the solution to encourage the out-of-box thinking? So far, we have not affected this kind of solution, but how is your team able to think out of box? What tools were used to evaluate the solution? Right? Whether the solution really exists or not. Have you used any tool to check, and evaluate the solution? What lessons from the pilot study? Before implementing the solution, it is always a good idea to implement it in a smaller scale. What do we call it as piloting? What are the lessons you have learned from the pilot study? And what are the changes you have incorporated based on the pilot study? See, if you have funded any project, you will also be asking same questions, yes or no? Right? Because you have supported the team with the required resources. So how does the solution remove the sources of variation? Nothing but the root causes. Very important, because we need to definitely address the root causes. Otherwise, the problem will continue to happen. So how did you ensure that? That's very important. So steps: generate and evaluate solution, and then select the best out of the list of solution and reoptimize the solution, and then pilot it, implement it, validate it. Show data evidence of the process condition before and after the implementation of the solution. At the time of starting of the project, you have certain data. And now that the solution is implemented, you wait for 1 week, 2 weeks, and now you have some sufficient data. Same process, how is it performing now? You can compare CPCPK, you can compare rejection rate, you can compare yield, you can compare relevant metrics, and then prove to the management that the improvement is because of the project. It's not a random improvement. That means, again, it is a form of hypothesis testing. So the main deliverable is solution, the implemented solution. And these are the tools you can think of: benchmarking, creative thinking, nominal group technique, multi-voting. These are all various forms of brainstorming only. Of course, benchmarking is referring to the best practices in the industry. And select and optimize. For solution optimization, you can use design of experiments. Piloting, implementing, pilot plan, full-scale implementation, failure mode effect analysis, all of them can be used for the solution validation. If you can't do experiments in real time, you have got some softwares, then it is known as simulation. Clear? Any questions you want to ask here? Improve phase. If I ask all of you to talk for 2 minutes about what can we do to solve our problem of obesity. Will you be able to talk now? Yes or no? Earlier, just 15 minutes before, we were in the analyze space. I have shown a fishbone diagram, isn't it?
Yeah.
That time you all contributed nicely, and I am able to draw a fishbone diagram indicating all the causes. Now I am creating an opportunity for all of you to talk in terms of the solution. The scenario is different, isn't it? The same tool, but the scenario is different. Earlier, you are asked to talk about the causes. Now you are asked to talk about the solution. Imagine junk food is one of the causes. Now, how will you address the issue now? How will you ensure you are not consuming junk foods anymore? Tell me.
We will start
What can
consuming home food.
you will start consuming the home food only, because earlier you have the habit of buying from the hotels. Whenever you feel hungry, you immediately buy something and eat. Now you have taken a policy decision, right?
Cooking
Not
at
to
home.
eat food from other sources.
Making a junk food no, instead of junk food, making a snacks at home only.
Very good.
And we
Yeah.
take it.
Yeah.
Making
Similar
food
food,
at
but
home
it is
only.
now healthier. Very good. That's a good point. You don't have to sacrifice anything. You can continue enjoying your snacks, your meals, but still it is healthier now. Very good.
Healthier.
So the support of the stakeholders is very important. Yeah.
Add fruits to your breakfast.
Yeah. Add some fruits to all your meal. Always carry some fruit so that you're not immediately what to say, deciding to buy the junk food. So always
And
there is
drinking
something in your
lots of water, drinking lots of water too instead of forget to.
Yeah. So you drink lot of water so that you never feel hungry, isn't it? Something like that. So now see,
Junk
the
food,
same tool is helping us, right? It is again the brainstorming, but the
Joining
tool
the
is
gym.
now taking us in the direction of solution. It all depends on how we use the tool. But all of you are very nicely participating. This is very important. Yes or no? If you have people who don't participate, they come and sleep on the table and they are of no use. And some people talking, taking us, leading us in some unnecessary direction. And they are also not helpful. So you need to ensure you invite the relevant people for the discussion and create the rules to guide every member of the brainstorming session. And then you will be, able to generate a lot of solutions. And then you will be flooded with solutions. So many solutions. Somebody asked us to drink water, and somebody asked us to eat fruit, and somebody asked us to make snacks within the house. And now evaluate everything, whether everything is possible. If everything is possible, yes, everything is possible if your spouse also agrees to prepare it, isn't it? Otherwise,
correct.
Otherwise it is not possible. You can't prepare everything in house. So you have to look at the feasibility also. And this is called evaluation. There are hundreds of ways you can fix the problem, but will your management allow that? Is the prevailing condition support that? That also needs to be understood, and this is called evaluation. So some kind of some rating, some kind of tabulation of the information in a presentable manner, so that your management will also understand your limitations, why you are selecting a particular solution out of the 10 possibilities. People will start loving the way you are addressing the problems. Everything is getting documented well. So this is what should typically happen in improve phase. So I think everyone is staying back today.
Sir,
Yeah.
I have one question, sir. See, based on your example only, the junk food is not necessary food. So we have to first think that the factor is essential or not.
Yes.
If not essential, we have to prohibit that. Same way in our manufacturing process also, some of the factors not necessary but forcibly it is exist. So we have to identify those things. We have to eliminate from the process.
Yes. Eliminate all the junk items from your house first.
Yeah.
Just
Yes.
because they are present, we are consuming.
Yes.
So you eliminate everything, then the chances of consumption will drastically come down. Good point. But problem is we don't know which is junk food, which is correct food. That is the problem. We think that everything we eat are good, but actually everything, has some problem. Okay. Anyway, it's a good point. So let us proceed with the control phase, and that will also, help us to conclude our program, particularly, for the yellow belts. But however, we will continue to learn every phase. Again, one more run. As I already mentioned, we'll be going through the DMAX cycle 3 times. And so you will feel a significant transformation every time we go through the cycle. All right. So control phase, here the goal is to develop a control plan. Here the objective is to develop a control plan. After the development of the control plan, even if somebody brings a plate full of junk food, you will outrightly deny. Yes or no? Because you have a control plan in place. Your mindset, has changed now. No, that's the kind of, control measure we'll be taking. So the tollgate review questions, the steps and deliverables, and then the tools that can help you in the control phase. Is there a control plan in place? Is there a control plan in place? And then how the input, process, and output variables are getting checked to detect suboptimal condition. Right? No, don't wait till the process fails completely. Can you detect the suboptimal condition even before the failure can happen? Possible. How will a new customer requirement be communicated to orient the process towards meeting the new specification? If the customer himself changes the requirement, is your process currently equipped to respond to it? That is also important. Our control charts exist. Our control charts used. If you are not using it, why? Because it's very, very powerful tool. Control charts can be used in all industries. Even I can use control chart here right now in the training program. Yes or no? If the number of participants count is abnormally varying, there is something wrong from outside. Yes or no? If I continue beyond 10, 15, 10, 30, I can see the attendance dropping. Yes or no? So control charts can give the correct signals when, your process requires some attention. So are control charts used or not? And what key inputs and key outputs are being measured? Right? What are the Y variables and X variable you are continuously monitoring and controlling? So the steps: implement the control system for all critical X. There are 3 X factors you found as critical. And now all the 3 factors were monitored on a daily basis. Some factors on hourly basis, depending on the criticality. Then document the solution and the benefits. Whether the project is a success or a failure, you must necessarily document, right? And document the lessons learned. And then if the project is successful, then hand over the process back to the process owner. Your job as a green belt, yellow belt, black belt is over now. You have to hand over all the responsibilities, all the knowledge you acquired must now be, transformed to the process owner so that they will take care of the process even in your absence, right? So these are the steps, and ultimate deliverable is control plan. What to do in different scenarios of, failures or indications of the failure. If a failure happens, how to react. If there is a signal about a failure, then what to do in that scenario. That is known as control plan. How to detect failures, how to take samples, right? And how many samples? What should be the frequency of audit? All these things, suggestions should appear in your control plan. So the tools, implementing the control system for critical X. An X bar R chart is a famous chart predominantly used in many organizations. X bar or control chart. X bar is average, R means range. And control chart test, control plan, POKI, lessons learned document, cost benefit analysis, project handover document, project closure document, and these are all the steps and tools in your control phase. So what is POKI? POKI is a lean tool. It's a Japanese term which stands for mistake proofing, right? Preventing the preventable failures, right? Whatever you can actually prevent, yes, you can prevent. And see here, in this case, there is a drilling machine and it is used to drill a hole. In the first case, there is no stopper attached. Whereas in the second case, can you see a stopper? The advantage of having a stopper is over drilling can be prevented. All of you agree?
Yes.
It's a kind of POKI. Here, it avoids over drilling. At the same time, it triggers a buzzer. Additional way of visualizing the mistake that is about to happen. So these are all known as POKI, and these are self-illustrative. There are three types of POKI: shutdown POKI, control POKI, and warning POKI. I forgot to charge my laptop. Now the battery is below 10%. You know what will happen to my laptop? My laptop will automatically shut down. Yes or no? There is a program written. According to it, whenever the battery is below 20%, it will become red. It's a kind of, what to say, warning POKI. If it is, I don't notice, then battery goes below 10%, then my laptop will shut down on its own. That is a shutdown POKI. A machine is running and somebody, unknowingly opened the shutter of the machine. Now the machine will detect that abnormality and then automatically shut down completely. Because when during the running of the machine, no, it is not actually recommended to open the doors, isn't it? So if somebody mistakenly do such things, then the machine will shut down automatically. This is what is known as shutdown POKI. You put your ATM PIN number wrongly more than 3 times. What will happen to your ATM card?
Block. It will block.
That is a prevention mechanism. Yes or no?
Yeah.
The system detects some unusual thing because you normally remember it. But how can you put 3 times wrongly? So it temporarily blocks your card. And after revealing your identity, you can open it. So these are all mechanisms to prevent failures from happening, known as shutdown POKI. Can you do something in similar line so that your process can detect failures before they can happen and then prevent failures from happening? Possible, yes or no?
Yes.
All that required is some effort is required. And there is also another type of POKI known as control POKI. That means your process will not allow the part or the particular step to proceed to the next stage. Say, for example, you are starting your car. The door is not locked properly. Now your car will not allow you to start the engine. You might have noticed, isn't it?
Correct.
But once you lock the door properly, then car will allow you to start. What kind of POKI it is? Control POKI. It is not allowing you to move on to the next stage. Similarly, if something goes wrong, your process itself will stop and seek for attention. Isn't it? That is a kind of control POKI. Then warning POKI. You are not putting the seat belt while driving a car. Now can you notice a buzzer sound coming?
Right.
That is a kind of warning POKI. Similar mechanisms you can install in your process also. It can be manufacturing or whatever. So what do you see here? Some kids are crossing the railway track, but what is the thing here? Only light is glowing, isn't it? The light is installed here and which can only indicate the whether a train will come or not. So this is a kind of warning okay. Yes or no?
Yes.
But what is this? I'm putting a gate here. This is now enhanced. This is now control. So similarly here, there is a small improvement made in the design. An additional drain hole is given. The purpose is to prevent overflowing of the water. If there is any clogging happens here, then this hole will, help you to certain extent. This is a kind of okay. Can you feel another okay here? The slipping of the screwdrivers can be prevented by changing this, slot in this manner. Yes or no?
Correct.
You call it okay, or you call it Kaizen. In both way, it is accepted. So you should always document your solution and the benefit, right? Always document whether it is a success or a failure. If it is a success, please highlight how you made it successful. If it is a failure, please document what went wrong. Like India won the one day 2020 World Cup. But one day ODI World Cup, they lost it. But there are learnings from both the tournament, yes or no?
Correct.
So that learnings are helpful for the betterment of the team in the future. So same manner, every project, whether it is successful or a failure, lessons learned must be documented, and that must be made available as a reference for the followers within the company. And if such documents are available, later on horizontal deployment is possible. You can also call it replication. Otherwise, they will be available as a resource. So project benefits, you need to perform the cost benefit analysis. Type down all the cost of poor quality, all the benefits, all the project expenses, and make a comparison. How much you invested and how much is the return from the project. You can make a ratio out of it, isn't it? Cost benefit ratio. If cost is written on the numerator, benefit is written on the denominator, then cost to benefit ratio must necessarily be smaller than 1. Yes or no? If you write benefit on the numerator, cost in the denominator, then it should be more than 1, right? So perform all of that cost benefit analysis and indicate it. And your project closure document should have the result of the project, all the control activities, status of any incomplete task. You expect the process owner to take care and take approval of all the stakeholders and then close the project. Now you can transfer the process back to the process owner and declare the project closure officially. And now your project closure should contain all of this, a control plan and review meetings, updated flow charts, SPC measures, out of control action plans. If my control chart gives signals what to do and all of these things, should be part of it. So this is a kind of project closure document, see here the reason for closure is written, and then, it is signed off by the project leader and the stakeholders. So finally, while wrapping up the closure, the team might consider evaluating what went wrong and what went well, and everything, you should be able to highlight. And management may also devise some rewards to recognize the good work done by the project team, right? And hence the success of the team. Because recognition and celebration of a successful Six Sigma project will drive process excellence philosophy within the organization, and hence managing the change will become more and more simpler. Otherwise, there will be a lot of resistance. But if people are celebrating their success, obviously that will motivate others also to participate in similar activities, similar projects. So that's it from me. Thank you very much, all of you, for patiently listening to me. I'm sure you all now, could feel how the, DMAX cycle will be going on in a improvement project. And you might now could have understood your responsibility as an yellow belt. There are several things the project leader has to do, yes or no?
Yes, sir.
Yes. And the responsibility is not very easy. right? It's not something light. Definitely a lot of challenging responsibilities he has to fulfill, and so that project can actually deliver the result. So as an yellow belt, your job is now to nicely support the project leader, understand the work assigned to you, because you as an yellow belt, you as a project team member, you are supposed to assist the project leader mainly. So whatever is the work assigned, if any data to be generated, and do it in a careful manner, right? Because you know the purpose of collecting data. So data cannot be, just like that generated. The purpose of the data is to understand what is exactly happening, isn't it?
Right.
So you must definitely put efforts to collect the data in an error-free manner. All right. So any questions, feel free to ask. Otherwise,
Sir, I have
we
two
can
questions,
proceed.
Rahul, to this side. First
Yes.
is like we received half of the slides and half are balancing. So you are going to give those also?
Actually, what you received, is actually a better version of the slides. That definitely, will cover all the slides I used. But even then, to avoid confusions, I will share.
Okay, sir. That is one thing.
But as far as the
Second,
yellow belts, I have used the same yellow belt slides.
okay.
Because
Second is
even though you joined for the green belt, and learning the basics is important. Yes or no?
okay.
So
And
that
second,
when I add up to the learnings, then it will make more sense to you. That is the
okay,
idea.
okay.
So anyway, don't worry, I will be sharing. Yeah. Yes,
Okay,
Shubham?
sir. I have
sir,
one
yellow
another
belts.
question also.
Yes.
So my second question is like we completed that yellow belt,
Yes.
and next month green belt exam seminar is again there.
Yeah. Every month we are doing a batch. We conduct two batches every month. One regular batch, one evening batch.
Okay,
Evening
okay.
batch is like this one, 7 p.m. to 10 p.m. Regular batch is 9:30 to 5 p.m. It's a kind
Okay.
of fast track learning. People who could not spend a longer duration, who want to complete the course faster, they can join our regular batch. Next Saturday, 10th of August, we are starting another batch, 9:30 to 5. 24th of August, we start the next version of 7 p.m. to 10 p.m. batch. Next batch.
Okay, sir. So, sir, I would like to know one thing here. Like in yellow belt, we complete the DMAC, and in green belt, we will go deeper dive, or some additional things are also there.
We'll deep dive the DMAC, but there will be a lot of additional tools we'll be learning.
Okay. So most probably, sir, next month I will join the green belt because. Okay, sir.
Most
And
welcome. Most welcome.
and sir, for yellow belt, we have to give some exam, or we will get the
Yeah.
certificate.
There will be an examination coming Saturday. That is next Saturday, which is a very simple examination. 30 minutes exam. There will be 45 minutes exam. There will be 25 questions. You
Okay.
should be able to score 60%.
Okay,
And
sir.
above. Yeah.
Sir.
Thank you, sir. Thank you for clarification.
Sir.
Yes.
Sir, I have
Yes,
an
sir.
experience around 15 years of experience in the pharmaceutical industry, in the operations and quality management system. So now, can I join into directly on black belt, sir?
Sir, definitely. You have seen our approach, right? Whether you
Yes,
join our green belt or a black belt, we teach you the basics.
So even whatever the concept are having in the green belt, it will come into black belt also.
Yes. See,
So directly,
yellow belt, green belt, and black belt, all of them have certain things in common. Agree, all
right?
of you?
Yes.
Right?
Okay.
So those common things are what we have discussed right now.
Okay, sir.
Right?
Right,
So,
sir.
but definitely, there will be new knowledge, new tools getting
Yes, sir.
added
Yes,
in the green belt level as well as in the black belt level. So, experienced people, yes, you can definitely consider,
Sir, even in the
joining.
black belt also, only online sessions are there, or even offline also is there?
Offline is available in Chennai.
Online, sir, is available entire session.
Online, I said, there are two batches every month we are doing.
Okay, sir.
9:30 to 5. Other one is 7 p.m. to 10 p.m.
On weekends only.
Weekends only, yeah. People are asking for weekend only.
Right, sir. Right, sir. Thank
Sir,
you.
is it compulsion of project in yellow belt certification?
No, project is not compulsory. Project is
And
not
in green
compulsory.
belt?
However, if you want to work on a project, that is highly appreciated. You start a project and then you can take our help.
In green belt?
Yellow
What
belt.
about the app
In
application?
green belt?
Class plus application access or
What
recording?
application?
Class
Yeah,
plus
record.
application.
Yeah, class plus application access will be available for minimum 1 year.
Okay. No, we not
And
got the link. That's why.
yeah. Please follow the procedure so that you will gain access to the recordings of the session you have attended, and you can revisit whenever required. Additionally, if needed, you can follow me, and for some updates, some useful videos, I'm available in LinkedIn, Facebook, as well as the YouTube also. So you can follow, you can those platforms as well. And some of you asked a question, right? Yeah, project is mandatory only for master black belt. Project is mandatory. That means after completing the black belt, you should definitely do a project. Right? Definitely do a
Is
project.
it
Then
not
only.
compulsion in green belt?
Yeah, not compulsory, yes. But they are good for your career growth. Because there are certain, challenges if we make it compulsory. So that's the reason why project component is not part of your certification. Your certification is purely based on your participation and your performance in the examination. Right? But if any of you do a project, we will be issuing you a separate letter stating the completion of a project.
Completion of project.
Yes, that is one thing. But we ourselves will demand for a project if you come for an MBB level. All right. So you can't proceed to the MBB level without doing a project. So you can go up to the black belt level, but after completing black belt, yes, you have to do at least one project. Doing project is good actually, but there are practical challenges, isn't it? Your company should support, you must have time, we must have time, and all of these things. But we can always support you with some, some completed case studies that we can always, equip you. But I strongly suggest you identify the project and initiate something and then come back. We will certainly be able to help you. Okay.
Sir.
Yes, sir.
Sir, every month, minimum 1 or 2 customer complaint. We are doing all the exercise.
Super.
Only one is a shortcome. This regression analysis we are not doing. So I want to learn that. After that, can I submit the actions what we have taken as a project? Can I get after completion of
Even
this
now also,
black belt, then master black belt?
Even now also, if you have already done, see, it's not that your regression analysis should compulsorily be present in your project record.
Okay.
So whatever project you have done, yes, that will definitely deserve the appreciation for that. But if there are some gaps will exist everywhere, we can upgrade. We can suggest you to upgrade. If you already done some project and there are some deviations, there are some mistakes, we will let you know on that. So what will happen? At least in the document, you can improvise.
Okay.
Since even though the project got over already, you can still improve the project document and you can present it, in a much better manner during the next opportunity. That is our idea.
Yes.
So at the same time, you will also understand the regression. Yes.
Sir, master black belt will be done in December now. What actually I had.
Yeah, December. Master black belt will commence in December. We'll only take 15 candidates once in 6 months. Any of you seriously interested, please pursue it seriously and communicate to us well in advance.
Sir,
Tell that you are planning for the MBB, and so we will guide you accordingly.
Sir, I'm communicating today and I'm even ready to pay also if anything need to be paid.
Perfect.
So I am very clear that I need to do that project.
Sure. And early enrollments, yes, we can even help you with the project if you could enroll early. Because if you come in the last day, last moment, then project must be readily available. But if you join early, we will have enough time to evaluate your work and then suggest you, or if anything required to be given from
What
our
is the
side,
charge,
that
sir,
also
for
we can
that
do.
master black belt?
What is
the charge for that?
47,200, sir. 47,200 rupees. And that has certain 3 components. One component is training, the other component is project, and other component is assignment.
Okay, sir. So, considering this black belt, till black belt, I am already enrolled. You are aware that. So, will that? Okay, sir. I will call
We'll
you
guide you,
personally
sir.
then.
We will guide you. Don't worry. We'll guide you. I think so far we have enrolled about 5 or 6 candidates only. Any of you who are interested, you can communicate to us. Either directly contact me or any of our team member Prabhakaran, and we will guide you. And then in fact, some interaction will also start.
Directly we can join that master black belt, sir.
Okay, sir. Okay.
Yeah. Okay.
Directly
Anything
we can
else?
join master belt or black belt.
Is there any exam
No,
for
no.
this
Black
course?
belt you must complete. You must complete the black belt. Afterwards only you can enroll. Black belt is compulsory. Project is compulsory. All right. Thank you very much, all of you. We'll be posting a link in the WhatsApp group. Please do write your review and experience so that people who are aspiring to join Six Sigma program will come to know about the level of quality and level of standards they will be experiencing in our platform. Right? So those of you, particularly the yellow belts, you are completing today. Wish you all the best and see you again in the next program. Thank you all. Bye-bye.
Okay.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.